Day Loop. Hello, everybody from the boost this Saturday, this beautiful Saturday. We survived Ian. It's just clouds outside right now. There's no rain. Hope everybody is safe and got through all of that. Um, and we also just concluded like 4 hours of home lab setup. If you can notice over here in my corner, um, that I do have a rack with all kinds of fun stuff on that. But I'm going to troll you. You're going to have to tune in to Home Lab and It to hear about that and ask me questions about that. But if you want to run your own lab at home and you want to learn how to do it and get good with Kubernetes and hacking and pen testing and password cracking on a supercomputer and that kind of thing, come for Home Lab and It. We talk a lot about Kubernetes and Docker and that kind of thing there. We're not going to do, actually, speaking of which, I've been trying to decide because we're on this is week 9, what is it, week 20? 20 or 19? Week 20. So we're on week 20 of the boost. It's the longest the boost has ever gone, hands down. And there's a good chance, I mean, there's only 52 weeks in the year. There's a good chance the boost is going to end at about the end of the year. And that's fine. And I messed around with some of the challenges to get rid of them. We decided this week that we're going to put a REST API Go into this, which is something I just did. I did a video on this this last week. If you were interested in doing gin testing and setting up a REST API and you don't know what that is, we don't talk about what REST APIs are, but if you want to watch me make one, there's a playlist. The Go playlist has a video on YouTube for that. So I moved a bunch of stuff like Zet and Crypt, and there's no bonzai. There's no bonzai here, and I promised I was going to learn you bonzai, but we are not going to do personal bonzai monolith. And a lot of people are going to want that, but we do not have time to cover that right now. So I will cover it, but it's not going to be a part of the boost because we have other things in the boost we need to do. We still need to do web dev a little bit. We need to set up our resumes. We need to talk about getting a job. We need to talk about what comes next and stuff like that. So we have a lot to do before we finish the Go. This is the first time we've ever done coding to this extent in the boost ever. So it's definitely pushing the boost out. And again, the boost is designed to just get you started, to give you that boost on your bike, and keep you pedaling. It's not designed to do it all for you, but we are doing things much more slowly because I'm doing it with you this time. All right. So here's what our goal for today is, okay? Our goal is to get that ready of these projects. These projects all cover stuff that you normally cover if you're reading a book, right? They're just in a project form. So we're going to cover Args, which talks about command line arguments, which we've already done. And this is just kind of, solidifying that knowledge that you already know because we did it in all the other ones. I wish we could do bonzai right here, but we're going to do an 8-ball program, which is one of the most famous programs out there. It's also my most popular, hands down. All the years I've been teaching this stuff, 8-ball is by far the one that people like to do the most. It's just fun and simple. We're going to do a really simple program that counts in binary base 2. We're going to talk about what bases are and get really deep into that. We talked about it a little bit when we were looking with ASCII terminal, ASCII character set and the ASCII terminal escapes last week, but we really have to reiterate that. It's super important that you understand that for just in general, all of computing. We're talking. If we get to it, we'll do waffles, the Do You Like Waffles video, which is a great way to test, if statements and synchronization and timing and things like that. And we probably won't get to the bridge keeper, which is really fun, but that'll be a great one to start with next week. So that's our goal. Okay. I am going to set the Pomo timer so that we can stay on track and take breaks when we need to. We're going to actually make a Pomo timer. That Pomo timer, we're going to code it and we're going to do all of that. And if we do the Pomo timer, it will actually be potentially a bonzai command. I'm going to put bonzai as a question mark. Okay. Because that would actually, we could do the two things at the same time. Yeah, we should probably do that. And then the story game could be, you could use bonzai for that too if you wanted. Yeah. Yeah. All right. Anyway, let's get going. So, let's keep that up so we can kind of keep track of what we're working on. So let's start, you should have, so if you don't, you should have a directory, you should have a Git repo or someplace that you're putting everything. We're not going to cover that. And you should make a project. So you should really know this by now. We're on like, week challenge, whatever, like 6 or 6 or something. And you should know how to do this. So how do you make a project, right? We're going to make a project called a command called args. Now in this case, we don't want a library. We don't need a package library. We just want main. We just want a command that's going to run. So we're going to make a directory called args. If you want to, you can actually put an extra R in that, and like args, like we're all pirates here. The only purpose of this particular project is to help you understand arguments so that you can create your own learning tool. Right now, it'll be useful. It'll fade off in usefulness over time because you'll just be able to look at anything and know the arguments. But this tool will help you automatically see the arguments to anything that you would ever use on the command line, in case you're confused. Okay, so yarg, yes. So we're going to go into our args directory, right? And let's go ahead and split this window up. And why? Because we're going to make a test program, right? So in fact, let's start out with the test. So we did this already. I don't want to do it again. So we already made a program, a bash program called gontr, antr test. We already did this. It's in my dot files. There it is, right? So what does this do? Anybody remember? It runs the ENTR program. The ENTR program does what? It says if any of the files listed in find dot, which we've covered long ago, that's every file in this current directory and every recursive subdirectory. If any of those files have changed, run this. And so it clears the screen and then it runs the test code. Okay. So just a reminder, that's how we're doing our testing. So I can just go into your tests and it'll do it. It's like, oh, there's no regular files to watch, right? Because there's nothing to test, right? So this is one of those cases where we're actually going to use main this time. So we're going to write a private set of tests. All right. There's also no files there. So let's make a file, right? So how do you do that? How do you make a Go project? Right? So we're going to do go mod init. You can't do testing without a project. So we're going to do go mod init, and we're going to go ahead and use this big GitHub thing. You actually don't need this. You don't need it. You could just put example if you wanted to, but go ahead and put that. Go ahead and put it. It's not going to hurt anything. All right. So now go to mod regarding home labs. Well, we're in the middle of a boost right now. You'd have to ask during home lab init, my friend, or during QCA. If you have questions, there is a question conversations advice every day. It's on the calendar. And we have a Discord for that, and we also have. So I kind of got to stay on track here for the next 4 hours. We will be taking a break, though. As soon as this 47 goes to 0, I'll be taking an 8-minute break if you want me to answer your question for you really fast. Okay, so we can save your questions for then. Yes, absolutely. It is possible. Yeah, but that's not a relevant question to what we're talking about right now. Okay, so here we go. And so we got our go mod here. And then what? So go into R, it will now run. It's like, okay, there's nothing here. I see no Go files in here, but all right, it's trying to do a Go test. So let's make one. We're going to make, vi main.go because it's in the main package, right? And vi vimgo actually makes this for you. If you save it, we can save that. And we actually don't have a test. We don't have any test code, right? Remember that thing about testing being hard with the main package? Well, we're going to take that and amend it a little bit because we're actually going to test this, the main package, but we're going to use the other. Notice that I'm not going to put underscore test here. I mean, I made a big stink. I did, right? I made a huge stink about making example tests because you get documentation for them, right? But at a certain level, sometimes you're not going to be able to do that. And you're just going to want to privately test the stuff in here without it becoming a part of your documentation. So we're going to cover the other part of testing that unfortunately people usually default to first. And that type of test, the first thing you need to know is it does not have underscore test, right? And it's private. It's private. This means it's in the same package as the other. That means I can test anything. I can test private code. I can test any code at all. All right. So I can test. I can test anything. So let's test. Let's do this. So func. But instead of it being example like we did, remember we used to have like example foo, right? This is how we used to do it, and we have output, right? And blah. That's an example test. Well, you can still do example tests, but they're not as useful here because, you know, they're kind of private. No one's going to see them, but except for the developers. So in this case, let's go ahead and just go full, you know, internal testing. And we can kind of geek out here. We can say testing. We can say testing, right? And then so that's the word is testing instead of example. And then you put the name of the thing. So we can say something like, we could say print, right? It really doesn't matter because it just doesn't. So, but this does matter. So we have t star testing.t. Now the reason I don't show this to beginners a lot of times is because they're like, what's the star about? And now we are off on a conversation about pointers, and we will eventually get to pointers, but I don't want you to worry about them too much now. A pointer is just a pointer to a thing instead of the thing itself. That's it. And understanding pointers are a real important part of most, you know, high-end programming. So we need to cover it. Rust, of course, will hit you with pointers right the first day. And C, of course, will hit you with pointers on the first day. So this means that this is a pointer to a big old struct instead of like putting that entire thing through. A struct is, of course, a collection of we haven't really done a struct yet. We're gonna get there. It's just a star for now, okay? So, but you notice there's no output here, right? So, and then you can use a whole bunch of stuff for T. And if you want to see the testing thing, you just go over here and you should be able to shift K it, or you should be able to go to another thing and do go testing, and go doc testing. And that will tell you everything in the testing library you can use. You can go to the internet and search if you prefer to do that. And this is going to tell you everything about testing. Okay. There's erase detectors. There's all kinds of stuff. Now you know where to go, right? To go read about it. It has fuzzing testing, which is added in 1.18, which is really cool, especially if you're in cybersecurity. And so here's the example-based tests, blah, 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 right? So, but we want to see this stuff at the end. So what are the different methods from testing, right? Well, we want this. We don't want run examples. We want some of the general tests. You really should read the whole thing, actually. And there's no better documentation than the actual docs. Don't read a book about it. Read the actual docs. And so, yeah, you can actually run the tests if you wanted to loop through a whole bunch of tests. So as I said before, these are much more complicated than example tests. We know example tests. We've been doing them the last 3 times. So now you can go look in here and dive in, right? So here's an example of our is it test or testing? I thought it was testing. I think that might be a bug. Did they change it to test? I think they might have shortened it. Yeah, I'm curious. It's a good thing I'm reading the doc. I want to say they've shortened it. That would be fantastic. Yeah. So there's an example-based test. Let's go read it. Example perms. Remember that this is our example test. We already know about those, right? That everybody ignores, even though they're covered like right away. Benchmarks. Oh, benchmarks are so cool. You can actually do performance testing using the benchmark. We're not going to cover that at all. You're going to have to go look at that. It's so cool that it's built in. It is test. They shortened it. Or has it always been that and I just haven't used it for so long? It is. It's test. It's test. I test print. The point it was testing. Okay, thank you for that. I just completely lost my mind there for a second. Yeah, I thought it was testing. All right, never mind. So we can actually have this fail the test automatically, right? Use test. Okay, good. Yeah. So let's try this again. There, it failed. We have a test and we made it fail, right? You want to make it pass? Pass. Right, pass undefined. No, you want to do, what is it? Is it okay? Has no field of method pass. It's been so long since I've used test bases, I'm going to have to look them up. I thought it was pass. Is it just fail? Or is it okay? I can't remember. I don't know. Anyway, we'll look for the testing struct. Give me a second here. Testing.t is where all that stuff is. There we go. Failed, fail, log, name, parallel, run, skip. Oh yeah, you can skip tests. I forgot about that. I guess if you don't call fail, it passes, right? Yeah, that's what it is. I remember now. All right, we pass. We pass, yay, because there's nothing in the test. So, but, you know, we can put something in the test. That's why we're doing this. So what do we want to do? We want to write a program called print. And it has to be lowercase print. I mean, we could make it lowercase print or we could make it capital print like that, right? That just means we would export. Exporting in main doesn't make any sense other than to keep it from conflicting with the internal print function. I mean, you could say output if you wanted. You know, I mean, output. No, I never use frameworks for tests, ever. I use the built-in testing always. Using Testify is a huge mistake in my opinion. It overcomplicates testing unnecessarily and creates an unnecessary dependency on something critical in your infrastructure, especially now that you have fuzzing in the built-in test cases. I won't use it. If you want to use it, that's fine, but I don't. I think it was a huge mistake that anyone even started using Testify. Guys who made it's a great guy, you know, Golang guy, or the Go time guy, but I hate it. I really hate it. There, you asked. So this is interesting, right? Because how are we going to actually test the output? Well, we'll say that the, let's say we'll make the output return a string, okay? So we'll say, we can actually do this with an example. This would be even easier, but we're going to do it this way on purpose. Say out equals output, right? And then we could say if the output equals this, you know, then, or how about this? How about if it doesn't equal that? So if the output doesn't equal this, then t dot fail. You can also do t dot error. If you do t dot error, it won't fail the whole test, if I remember right. Yeah, error. Here's some noises somewhere. So error is equivalent to log followed by fail. Yeah, so this will actually give the error. Fail doesn't let you put anything out. It just fails. It doesn't take any arguments. No, I don't. No Python here. I did Python once upon a time. Yeah, I used to teach Python for all this. You can actually do your own Python on this. Yeah. This stuff, I used to teach all of this stuff as Python instead of Go. But yeah. So fail, let's do error instead. Let's say error, and you could say was expecting this, right? But got. You can also do error F, which is always good. I like error F because then you can do this. You can do want V or Q, right? And then you can do got another Q that quotes it. That actually quotes it out so that it looks nice. And want got, right? And then you say, you know, you wanted this and you got out instead. All right. Undefined output. So we haven't made an output yet. That's a good error. So now let's make it main.go. And as I said before, we're going to keep our main function really simple. And we're going to keep everything in functions, which is just a good rule of thumb no matter what. Your main function should always be really simple because you can't test the main function. All right. So it's just a good rule of thumb. On want, you can. You definitely do. You do. I mean, I like it, but you don't have to have that. Yeah, I just like them so they're left justified nicely. So yeah, but you don't have to. Stream description is not updated. You're right. You're absolutely right. Thank you for that. Let me take a moment to do that. Thank you for that reminder. That's why we're getting weird questions. We're getting home lab questions, and no wonder I'm getting home lab questions. I apologize to anybody that I barked at, because they were under the wrong impression that we're still doing home lab init and Kubernetes. And that's what the questions were about. I apologize for that. Deeply apologize for that. Paste. We are in software now. We're now in software and game development. Golang done. Okay, category is updated. Project. There we. What? I just changed it. How come it's still stuck on the old one? Did it get to the new one, my friends? It should be. It should be on the new one. Is it there? Week 20. I am so sorry for that. It updated? Okay. Thank you. Okay, so here we go. Then we need to make a function. So function output, and it's going to return a string, right? Now, what is it going to do? It's going to output something. So we can make the whole program just do that. We can just have the program just call output and be done. Even put it on the same line. And it's exported, but we don't care because, I mean, if you want it to be private and you don't want anybody to ever see it, you can make it like that. How about that? Let's do that. And that's kind of furthers our point here. So main underscore test. Remember I said that I tend to do internal versus private. We haven't actually, no, we covered that in Kubernetes, but not Go. So let's make it private. So it's lowercase. If anything in Go starts with a lowercase letter, anything but an uppercase letter, it is automatically private. That means the only things that can see it are other files in the same exact directory. That's it. Nothing else can see it. If you want to export something, you make the initial letter a capital, which I just changed it from. That's what it was before. If you want to get a sense of this, so error F, right, is exported. That's why it's a capital E, right? This error output here will work, but this is a convention from reflection that forces it to be uppercase, even though normally it would be lowercase. It's kind of weird, but that is a thing. So we have a problem here in our main program. So we need a return. So our output, let's return test. And we'll see our want and got are off, right? So in fact, I usually, for this kind of thing, because I want to have the nice, happy error messages, I'll usually put in a cone. I mean, you don't have to. You can have them be on the same line if you want, but doesn't that look nice? Doesn't that look nice? That's why I like it that way. In fact, sometimes I will even do this, get them to really line up nicely, want got, and so you can, write your own stuff there. That is essentially the same thing that an example test does. In fact, how would you do this? The same thing as an example test. Let's just do that as a practice, right? So let's yap that YAP to get that whole thing. Now let's change this output test to an example output. Just for the sake of reference, we know example output already, so let's do it that way. First of all, example output doesn't have all that crap, right? It needs this, but rather than doing our own error message, we can just fmt println the output, right? And then the got, we can just put output here, output : / and we can say what we're expecting, right? We're expecting this. And as you can see, the example output does almost exactly the same thing that we did explicitly in the tests that we wrote, the private test case. But I kind of wanted to start you off on the early thing. I actually think this one looks easier to read, but this one is exactly the same. So you can use example tests here if you want to. I just want to have that there so you can get a sense of it, right? But we're going to be changing what this output is depending on the stuff that's passed into it, right? And that is where things are going to get interesting. So because we're basically encapsulating So we're basically encapsulating all of the stuff coming from the command line and then passing it on, right? In fact, instead of saying output, you could say like run, or you could say do it, or you could say execute, you know what I mean? So this could be, and the reason for that is because yes, we can test the main program, but the main program is going to spit this stuff out to standard output, right? So we're actually going to change this. Let's change this. Let's say we could say output. We'll keep it as output or something. That's fine. But we want to be able to give it some args here. I mean, that's kind of the problem, right? So right now we can test output because we can go call it from the test case, and then all main does is just run it. In fact, let's run it. We can do that. So we can do go run main.go. You might remember this. And oh, hey, it didn't print anything out, right? Why didn't it print anything out? Well, it just returned test. It didn't print it, right? So let's do that. FMT println, and we'll give it a trailing line. And now we're going to print the output. So now we can actually run it, go run main, and we get our test output, right? As I said, if we wanted to test that without the function, we would have to, wrap it in a shell script or something. So we're just going to leave it like this for now. And this gives us something to test. So let's continue to test what this is going to be. So all our good, stuff is going to happen in here. That's why you could call it run or whatever you want. So let's call it, what are we going to do here? So when this works, let's actually tailor our test case a little bit more to give a sense of what it is we're building. This is the test-driven development thing. It's just controversial. People hate it and love it. But the idea is that you kind of think about what you're making before you make it. So we're going to have output. We don't want this output to be just this. We want this output to be something else. So let's actually use a constant, okay? And we're going to put the constants up here. So we'll have a constant up here, and we'll have it be, let's say we want, what is a test case that we would want to pass? Oh, okay. First of all, how are we going to change the output, right? So, I mean, let's just jump right back in. So we wanted to print out the arguments. We already know about arguments because we covered that, right? So simply put, we could just do fmt println. We want to make it prettier than that. os.Args. You already know about this, right? Because os.Args is a list. You remember in Bash we learned about arrays and lists and stuff, right? So os.Args is just a list. And in fact, if you want to see what type it is, if you don't know what type it is, you can actually make your own little debugger here. You can say, I want %t, which will print the type. And then you could print the actual thing, right? So you could say the string rendition of it. So let's run that. T needs 2 arguments. Oh, right. So os.Args, you gotta have 2 of these, and you put 2 of those there. Wrong type. Is it %t or is it capital T? It's capital T. Okay. So as you can see, here is the value, right? And it tells you that the type is an array of strings, right? Or I'm sorry, a slice of strings. Arrays are different. So that's the thing you can do. It's kind of fun to check the type. But I mean, ultimately we want to print these args out, right? But we want to loop through them so that each argument, and look at this. I also wanted to show you this. So you remember I talked about the problem testing and executable in the main package? Here you go. When you run the test case, what it does is it automatically, when you go test, it automatically compiles the program into a program that it saves temporarily in temp. And that is a binary. And it gets deleted right after that. And then it runs all of these extra settings that are built into your tester. And so these are extra arguments, right? Well, as you can see, that would mess up our args thing, right? We want to print out the args. So, but let's go through this. So the requirement here is we want to make it so that when this thing executes, it's going to print 1 arg per line, and it's going to tell you what the argument is. arg1, arg2, arg3, arg4. Okay. So we're going to do a very basic for loop. And this might be new for you. Okay, we've done for loops in Go before that iterated over all the items, right? And we did some for loops in Bash that would count between a number and another number, and both of these ways are doable at this time. We can do both of them. We could do for to range over a thing. In fact, let me show you the first one. So we do for, and then we're going to ignore, well, actually, no, this is actually perfect because it does get the number. So we can do for n, comma, val, I'll say, and range, and then we're going to say os.Args, right? And then we have a block, and then we do, we can build up the string. All right. Now we want to buffer string. So we're going to say var buff string, and we're going to add on to the string while we build it up. Okay. So we're going to say, so we'll say what? Let's say buff plus equals. That's going to add to the end of the buff. As opposed, it's the same as doing buff equals buff plus whatever, right? It's the same as that. Instead of that, we're going to do buff plus equals, which in this case, the plus operator means append. It doesn't mean add to it, right? Because it's a string. So we're going to say fmt sprintf. Now, sprintf, we covered a little bit last week. Sprintf prints, it's the same thing as printing, except for it prints it into a string. So then you can print the string later. And so we're going to sprintf, yeah. So we're going to print f into, and we're going to use some things here. We're going to say arg number n percent v, and we could say, I put an arrow there. Okay. So you could actually do $ like that. That would give you the bash version, So let's do that. And then we'll say, we'll put a \n there, and we'll put the val. So this is going to be a quoted variable. All right. Quoted means that, like, if it has quotes in there, it'll put backslashes in front of it, stuff like that. Okay. And if it's a number, it won't quote it. It'll just do it as a number. So we're going to, everything is a string in arguments from the command line of bash. So that'll probably all have quotes around it. Let's go check. So so the first one is n, and then the second one is val. So as this iterates over it, you can see, wow, I like did a \n on that. You can see what it does, right? So let's go ahead, and then it returns the buff. Let's go ahead and go run this one, because I think it'll be easier to read. But you can see the test case is going to be tricky, right? Because we're going to have a lot of stuff to run here. And it's sometimes easier to just run a program. So as you can see, it printed out the program, right? And so when you do go run main.go, it only got the first one. It's like there was only one argument there, yeah? But weren't there more arguments? When we run it from the test case, there were 2 or 3 arguments, right? But watch what happens if we do it like this. And we do go run main, and we do blah, 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 blah. You'll see it'll give them all. It'll like argument all of those. So you can do go run, and you could say first, second, third, right? And when it's compiled as a program, it gets it right, and our program is done. Can you see how it temporarily compiled that thing? Kind of cool, huh? If you want to see what happens when you go build main.go, build main, that'll build it. Go build. And that will make us an args in the same directory. And we can run it now. And we run it, if we do our same thing, instead of go run, right? We just do /args. Why do we need /, by the way? Why won't args just work? Because it's not in our path, remember? It's not in our path. If we do go install, it'll put it in our path. But if we just do go build, it won't. So we're going to do this. We're going to do, so We do dot slash and run it, and we get our thing. Now, it's kind of lame that it's a println after that. I'm going to get rid of that println because why? Because it's already printing everything, right? So it's already, we don't need I mean, down here we have a println, but I think we should just use print instead of println. That gets rid of the line return at the end. And now when we build it, go build, it just assumes the packet, the name of the directory as the name. And then we do args again, and there we go. So there's our project. We're done. Now, the problem is we know it works, right? So is it really worth it to go about, writing a test case for this? That's kind of hard to say, right? But it is probably worth it, right? It's probably worth it. And so one of the first things you can do, and this is kind of a backwards way of doing this, but if you have a command that already works, you can cheat and you can go get the string and copy and paste it into your test case and just ensure that nothing's going to change, right? So under what circumstances would we want that to exist? So first of all, it's very hard to use strings. Test, we're going to do test one. We're going to make this our first test, right? And we're going to put this, so I'm using a backtick, which is a new thing you might not have seen. A backtick says keep the line returns just the way they are, all right? And so that's the output we expect, right? Put that in a constant. And again, we don't care about this being inside of the function block because it's not going to be going to documentation. So we can say test one. So if the output does not equal test one, then we're going to get an error, right? And so yeah, and then this needs to change to test one also. We'll save that. And you can see it totally did not pass, right? So the problem we have now is, well, it's not actually doing what we wanted to because the arguments are being pulled in. And then I wanted this. So we are pulling os.Args in, right? But how can we test the os.Args? So this function is not functional. In other words, it depends on things outside of its own scope. Okay, so that's what functional programming is, by the way. So let's actually put this in the README. Covered. Basic idea of what functional programming is. Paradigm. So there's different ways of programming. They're called paradigms. What is a programming paradigm? And we're going to breeze right through this. Programming paradigm is a concept by which a methodology of programming languages adheres to. Paradigms are important because they define a programming language and how it works. A great way to think of it is a set of ideas about a language. What exactly is a pre-code camp? The key principle of the paradigm is the execution of a series of mathematical functions. You compose your program in short functions. That's different. All right, so this is the most important one. A programming paradigm is a classification, a style, or a way of programming. I agree with that one more. And let me give you a sense of this. Okay, so you can talk about this for hours, right? So you probably heard about object-oriented programming. You've probably heard about functional programming. You may have heard of behavior-driven development. And I mean, there's different ways to approach programming. The two main paradigms for programming are actually three: procedural, functional, and object-oriented programming. Okay, and class-based object-oriented programming, which is really not the same. So I use the word functional here because I'm one of the reasons that this is broken is because it does not adhere to one of the most important concepts of functional programming. And you might ask the question, well, I thought Go was not functional. I thought Haskell was a functional programming language, or I thought this was that or was that. So Go is a hybrid language. And most languages that are wicked popular in enterprise and personally, privately, are hybrid. Python is the same way. Java is not. Java is a very, very strict class-based object-oriented programming language. C++ is extremely strict in terms of object-oriented programming, but any C++ program is also a C program, and C is very much a hybrid. You could write it however you want. It's mostly procedural. C is mostly procedural. Procedural just means that you can organize things into steps. And we talked about the word function versus procedure many times before. I don't want to go through that again. But the difference between a function and a procedure is all functions are procedures, but not all procedures are functions, true functions. And when you think of a function, think of lambda calculus. And if you don't know anything about lambda calculus, that's fine. You can just think of linear algebra. It means you put something in, you get something out, right? Well, I have a question. Who is putting in the arguments here? So here we have a machine. So if functional has no side effects. Okay, so Mossy's using the magic word, side effects, right? The side effects, but it's not just side effects, right? It's also limited scope, right? So you can look at like what constitutes functional programming. You can like spend forever reading about it, but I'll break it down for you. Yeah, the best way for you to understand functional programming is to imagine a math equation. The end. Okay. Does the math equation know anything about its outside environment before it runs? No. It has to be passed in as a variable, X or Y or something like that, right? A parameter. Does it do anything to anything outside of itself? No. Right? So, like, for example, what if I were to... So the reason functional programming is so popular, particularly, is because it's so much easier to test. We have a problem here, right? I really want you to understand why I can't test this code right now. Why can't I test this code right now? Spend a moment thinking about this. Okay? You look at my test code. Why can't I test it? I mean, I don't want you to just learn the syntax. I want you to learn these things because you'll hit these and you'll submit code and your seniors or whatever, they're going to freak out. You're like, I can't test this. How come I can't write a test for this code? There is no way whatsoever for me. There actually is. You know how I could do it? You want to see me do it and break everything else? This is called a side effect. I'm going to change the os.Args. Actually, I can't because they're a function. They're read-only. It doesn't have any arguments. Yeah. So I want you to see that problem because I'm pulling os.Args out of the air, or more technically speaking, outside of the scope of the function. The scope of a function is everything between the brackets, the block. Anything between brackets is called a block, a code block. So anything outside of that scope is kind of off limits in a functional programming language, right? So if you want to write Go, and you can write Go to be functional, procedural. You can make it even object-oriented if you really twist its arm. You can do that. You can code it in that way if it makes sense. But most of the time, the stuff that you write, you'll want to write it with the basic tenets of functional programming. So even though I can pull the os.Args out right here, why don't we pass them in? Why don't I say args here, right? And in fact, we could even make it a variable length. We could say I want one or more args, right? And they're always going to be a string, okay? It's like a hidden argument. Yeah. Yeah. So, but let's make it more explicit. Let's say, no, you need to pass this in. You need to tell me what you want. It's not that hard for us, right? So we can put args here, right? And we're good to go. So now we have something to test. And so now we can go to the main test here and we can say, oh, okay, I want the output of, and it will say, now we actually have to imagine, I mean, we can't just put first, second, third, right? We have to actually tell it the first one as well, right? This is a little bit interesting, right? Because we're going to be kind of lying about what's actually in there. Now our test still failed because we have the extra line return there. So let's fix that one right away. Yeah, let's do that right now. We have to put an extra. Well, that's because this is not on the same line, unfortunately, and it has to be on the same line. This is yeah. I mean, this is something that's kind of annoying. I'm trying to think of how we could do that. Anyway, so we could make out, okay, let's do this. I mean, I'm totally cheating here. I'm totally cheating. All right, so as pure or impure functions. Yes, yes, yes. You see that all the time. Yeah, pure functions. Because people have reused the word function all the time. So here we have, oh wow, what's this? So we got first, okay, this is right. First, second, and third. That turned out right. Okay. But the problem is that we're missing something. We're missing the first one, right? ./args. What? It's not, we didn't get a ./args, right? Our first argument was 0. And we actually don't want that, right? So we, in order to simulate this, we have to put here, like whatever, we want to pretend like it was the actual program, right? So if we had that, we would expect to get that as the output. So this test case is not particularly useful, but it does show, because you know, we're twisting its arm a lot in order to get it to use, because it actually does its own compilation and stuff. I mean, this is one of those cases where it's really easy to just look at the output, which is why unit tests can sometimes fail. Sometimes this obsession with unit testing is misguided. And we talked about this a lot this week during the other streams. Because obviously the best way to test this is to just run it and have somebody look at it and make sure it's right. You know, as soon as I get writing, I mean, this test is, not only is it completely indecipherable, but, you know, I have to tweak it. It's taking time for me to fix it. But I did want to show you, I mean, I complained about, you know, this type of unit tests before and how I don't find them as useful as example tests. But I do want to let this kind of, you know, overflow into the conversation about whether you should obsess about testing this kind of stuff in the first place. If you're just writing a little command, you know, this might not be the best way to test it. Maybe the best way to test it is just run it and look at it. And, you know, that's heresy in some circles to even suggest that. But you know, if you hear anybody fight about it, that's usually the basis of the fight. And I mean, here's something else. These are identical, but they're not matching. Anybody want to guess why? I don't know. So there's something about this thing that's not equal to the other one, and I'm missing like a character somewhere. But to me, they look identical, right? So at this point, I've like invested a ton of time in a test that I could have just run and watched. Or more importantly, in this case, done as an example test. In fact, I'm gonna disable this, and I'm gonna turn my example test back on. And even though my example test is not going to become a part of the documentation, I'm going to show you why I prefer the example test in this case, because we're talking about output, right? So now I can go back to my example test, and I can do exactly the same thing here. We'll bring this one up, and you'll see this. Okay, so see what we got. But now watch how pretty the test is, and I don't even need a constant up here. I can just put this whole block right here, and I have a little tool called go indent test. Wait, go test indent, test output, and that automatically indents it and puts it there, and now when I run it, my test passes. All right, even though this is a private test, which one's easier? Let you make the decision. For this kind of thing, this type of testing, this is called an example-based test, and this is a test-based test. These are both documented in the testing. If you do go -doc testing, you can read all about it. For the covered summary. And this, by the way, does get included in documentation. That's private, right? Because we didn't export the output thing. But if we wanted to, we could. If we wanted to export it, we could, and we could document it. But look at how much easier this is to even understand, right? So I am a huge fan of example tests. People say, why don't you use testify? Why don't you use test output? I see shit like this. I'm sorry, that's the accurate word here. I see complicated, almost impossible to understand test code that is written like this when they could have written it as a very, very simple example-based test. It's very human readable all the time. And every time I see it, I die a little bit inside because I'm like, you don't need to do that. But the reason I wanted to do this is because we were using main, and I wanted to introduce the other form of testing to you. And honestly, I wanted to make the case that this is always going to leave something to be desired. There sometimes you really like, if you want to test 100 different variables and you want to develop all those, you want to write all those variables in a loop and everything, and that's what fuzzing is, by the way. Fuzzing is related to that. It randomly picks a bunch of random things and sees if your code actually works. And those are the types of cases where you would reach for the testing framework. Otherwise, probably stick with examples, even if it's a private thing. Okay. Now I had to get rid of if I put test over here, what's going to happen, by the way? Failed. Don't know what it is. Now there is a fix for this. I mean, since it's just main, we could just go back to main. And do we really care that this is hidden from the world? Probably not. No one else is going to do it. In fact, if we do that, they can actually import it. That would be bad, though, right? If they did that, that would be bad. We wouldn't want them to import this. Oh, why the fuck? We wouldn't want them to import this, right? We wouldn't want them to import this. So I'm going to show you one last thing that I don't think we've ever showed before in the boost, and this is my personal preference, and it's also the preference of the Kubernetes team and a bunch of others. So their preference is to actually use exported symbols by default. And before you panic and say, but that's going to create dependencies and people are going to depend on me and they're going to use it. Right now, if I want to do import, RWX boost weeks 20, Args, I could import this and use args.output directly. But it would look really weird because I'm importing from a main package, right? That's kind of weird, right? So we can still keep the main package, or we can, do the right thing and do the command. Do you guys remember how to do this? So I'm about to summarize how we did this last time, but we're going to do it again. So we're going to make a command directory called CMD, and we're going to make a directory under CMD called Args. And I know that seems redundant, Args, command Args. And inside of there, we're going to move main into the command main.go versus, I don't know if they're property based. Is that what they are? I've just been calling them example based tests. That's just my word. I don't know if that's the official word. Okay, so now we have this main test hanging out here. It's like testing output, but we need to reorganize a little bit, right? We don't want this binary here anymore. All right. So now what do we do? Well, now we're back to a package, right? So, but we don't, okay. So normally when we did a package, we did this last week. Normally if we have a package and we want to import this package, we could say, okay, I want to get that code, that output function, right? I'm going to take it out of there and I'm going to put it into an args.go package. And I told you we weren't going to do this before, but I just can't not. Because it's just the right thing to do. So now the package is called args, and our main package is under CMD where it belongs. And now we have this beautiful kind of useless thing that we're going to call, right? But now what? How can we test it? So let's rename main._test to args_test.go, and we're going to do args_test.go. And here it is. We have example output. We changed main to args. And guess what? Now we have an exported functions. Random inputs. Yeah, there's fuzzing. There's fuzzing is a specific type in Go though. I don't know if you could get away with saying that actually. Okay, so as you can see, undefined output. All right. Well, why? Because we started doing testing like, God intended with, as documentation, in my opinion. So we have to put args here now. We have to actually make an example test that will work as an example test. I'm going to leave this broken test output down here just so you can see it. But now we have, a beautiful test that passes. Guess what? Somebody else can actually use our library if they wanted to call output. But something new. Let's pretend like we don't want that. We never, ever, ever want anybody ever to depend on that args.output. We don't want that. We don't want to maintain it. We don't want to make it public. We want to have it seem public to everything in this module, this module being all of these packages and everything in this module. The module starts with go.mod. That's the top level. So we want it to be visible to everything in there, but we don't want to make it so that, everybody else can see it. So we use something called internal. We make a directory called internal, and then we move all our args stuff into internal. And I may have done this before, but I'm just going to repeat it if I have. So internal automatically signals to the builder and to the importer, don't touch me. The only thing allowed to see anything with internal in the path is the same stuff in the same repo. So let's try to get our code to compile. So cmd, let's do go build.cmd args, right? And it's like undefined output. It can't find it. Okay, so let's go fix it. We have to use a library now, right? But instead, so it's output. Right now it's output. Well, it already knows about it, so we can do this. Internal.output. Now, usually somebody won't use the direct package name internal. You can, though. You can. Usually they'll put another directory package underneath internal, and they'll use that like api.output or something. But we're going to go ahead and put internal.output. And that should be enough, but we haven't, it doesn't know about it yet because we haven't built it yet. So we're going to go here and go install, and that will install the internal package. And now we should be able to edit. And if I save it, it will see it and populate it. It should anyway. Did I spell it wrong? Oh, wait. Well, we need to change the package name too. What do we want to do here? We could do two things. I'm going to let you decide. We can either make an args directory under internal for an API, or we can just change this. We can say args.go. We can change this to be in package internal. And I don't think that there's anything wrong with that. I've seen this not in a lot of production code because they generally have stuff organized in there, right? But there's nothing wrong with it. So let's actually try this. Let's try this, shall we? All right, so let's do internal test, and let's go back up and do our test again. So VICMD, did I not build that? Oh, there we go. Okay, so see how it pulled it in automatically? Because we now named it internal, and it says, okay, I know what to do, right? This should actually build now. So command args should build an args right here. .args first, second, and it didn't work. Why didn't it work? What's going on? Args. We don't have a test case. Let me go figure it out. We have a fail. FFT print internal output. Oh, because we didn't. Oh, silly me. What did I do wrong? We didn't pass any args to the output. I was supposed to do that before. I forgot. So what are we going to pass to this? Just os.Args. All right. And we're just going to pass. I mean, I know that's kind of contrived, but it works. All right. So let's do that. Let's build that. Build. Cannot use os.Args variable type string. Oh, okay. Another thing I forgot to tell you. So this is kind of getting funky now. So let's go back here. Right. So let's do one thing at a time. Let's don't combine them, right? Let's do an intermediate thing. So buff equals, or you could say out or something. It's not break time. Oh, I know. We're gonna take break time. Give me a sec. So we're almost done with this idea, and then we'll be taking a break. So out equals internal dot whatever, and then we're gonna do fmt dot print out. All right. But what I wanted you to see here, and this is something that we kind of glazed over, I apologize. You see how os.Args is a string? Well, in our internal library, what did we do here? If I take away the dots, it will work. So pay attention to this. If I take away the dots, then I don't get a variadic signature. That means that if you put the dots, that means one or more args. And it puts them all together and sticks them into a slice. If you don't have the dots, it says, I'm going to pass the slice, which internally is a pointer to a slice. But you don't know that. You don't need to know that. So this will work, right? Because os.Args is already an array of strings, right? it's already that if I pass that. There is another way to do this, though. I mean, that is probably the right thing to do. But if you wanted to make it so that people could change the stuff here, then you would do ... But if you do that, then you have to make it so you have to extend it like this. So then this says, okay, this output parameter signature is variadic. It takes as many as it wants, but this is an array. So let's spread out that slice. Let's take that slice and spread it out. And then this slice will fulfill the needs of an extended one. That's new. We haven't covered that before. So we're going to go ahead and go build. And now we have args first, second, and that should work. Okay. And that is a good place to take a break. That is a mouthful. I'm going to pause the YouTube video now, and we're going to take an 8-minute break. All right. So during the break, a couple questions came up that I think are important, and it's going to take us down a rabbit hole a little bit and Go. But I think it's super important because the focus on Go has been terminal utilities and applications, and you can't talk about that without talking about flags. And we're going to get into what those are. Some people call them switches. Some people call them options. There's lots of different names for that. And then we're going to talk about, things like what about Cobra and bonzai and stuff. What about, Cobra? What about bonzai? And I'm going to let you determine what we do with this. Okay. So the first answer, though, before we get to that, there's been a little bit of confusion on what actually happens when you use the 3 dots. Is it flag? Is it the flag? It's flag dot whatever, right? Yeah. We'll cover it. I don't use it that much, but we'll cover it. I use bonzai. Which we'll put like this. All right. So we'll get there. First, let's talk about arrays and slices and strings. So somebody said that when you use the ... notation, that, does it become a big old string that gets combined together? And the answer is no. It becomes an array. It becomes a slice. And then the terminology slice and array came up. Okay. This is the definition of a slice, which we did talk about briefly a while ago. A slice is probably what you're thinking of. If you've ever done any coding at all, you're thinking of a slice. If you've done, the bash program we did earlier, a slice is equivalent to a list, or what bash calls an array. And the difference between the word array and slice is really significant in Go. An array is like a slice, except for it can never change, and it's tied to memory. It's more like C. If you know C, an array makes C people happy because it's something that doesn't change, that's very hard coded. And a slice in Go is an abstraction that rests on top. It's a static array, right? A slice it's not a dynamic array, but it's dynamic in nature, and that's because a slice is a construct that looks down at the array and contains positional information about the array. Now, why would that ever be a thing? Yeah, the array is immutable, but the slice can be changed. But the truth is that all slices have an array underneath them. Okay. And the slice can be messed around with a bunch, right? And you can add stuff to the end of the slice. And when you do that, you actually end up concatenating the arrays underneath in memory. So you almost never use an array. And if you hear me correcting people when they're saying array, because that's the word used in Bash and JavaScript, the word is list in Python, and it's because the word slice is much more important. Arrays are also passed as value. And not necessarily passed by pointer unless you take a pointer. Slices are always pointers. So we haven't done dictionaries, maps in Go, but when we do, we're going to talk about that. So slices are an abstraction. So they're always passed by pointer, which means they're teeny tiny. To call it from a function, there's not a lot of data being transferred in any way. It's just a pointer. But there's no pointer there. It's kind of hidden behind the scenes for you. So if that's confusing to you, just know that just use slices and treat them like Python lists. And that means you can do things like you can like examine just one of them. Like, right, we talked about this the other day, but so like you could do in your internal thing here, if I wanted to slice the slice, I could say, so we made this thing that joins them all, right? We changed our thing. Let me show you. Oh, whoops. Oh, wait, I deleted it. Dumb me. All right, so here we go. So you see how we added this during the break. We added this, right? So this joined together the array, and I want to show you. So like I can put all kinds of white space here, right? And you see that it joins it together. And that's something we added, and I want to show you the code we did for that. So we just added a buff here. We added a strings.join. We added args. This again is a slice, and you can actually look at the signature of join. You see that join takes a slice of strings. And by the way, whenever you have a slice, that means if there's no number between the brackets, then you absolutely know you have a slice. Arrays always have something there, if I remember right. So anyway, I don't use arrays very much. So nobody does. And then you combine them and you get this thing, right? Now, if I didn't want all the args, let's say I want to chop the first arg off, I can say 1:, and that will give me, this is very Python-y, right? It gives me all of the values. The first one is 0, and so that means from 1 on. So the numbers will be different. So now when I rebuild it and I run this, you'll see the value is chopped off args, right? So it chopped that first one off. And you can do the same by, getting them from the end, or you can grab one out of the middle. So as I said, slices are abstractions that are on top of arrays that are the things that you almost always use. A string to a slice, a new slice is made. It depends. It's really nothing you need to worry about, but because it would be premature optimization to deal with that. But the answer is, it depends, as far as I know, because I think when if there's not enough room in the underlying slice and you're increasing the size of it, it'll make a new one. So let me give you a sense of this. So there's a package called sort, right? There's a package called sort, and it will take a slice and it will resort the slice without creating a new one. Because the exact number, all the slice internally is doing, if you want to care about Go internals, the only thing it's doing is it's changing pointers to all the different things within the array. And so it takes that exact same amount of memory and reorganizes that memory in exactly the same amount of array space underneath the hood. And it doesn't return a new one, which is kind of blows you away. When if you see or anything else, you kind of be like, what? They just reuse the same exact capacity of the thing that was passed in, because there's no change in length or diminishing in length. Now, as I understand it, and I don't know what the algorithm is, but if you add to a slice, if you append to a slice, you're building a new slice, definitely. And that's what the append function does, right? The append function, the built-in, not function, the append built-in will make a new underlying array with a new slice on top of that. And it has to do that because it has to reallocate memory. It has to allocate additional memory. And I'm pretty sure it's optimized to take the existing memory and go give some other ones, and you do the pointer and do a linked list internally or whatever. I don't know. But it does it, right? But it has to create a new one in that case because it's changing the size. If you're removing it, so there's truncate, there's no truncate, right? There's no resizing of a slice. You can make a new slice from the other slice, but it still points to the same array underneath, and it doesn't free the memory. That's important. A new slice, new reference in memory. If it's bigger, and this, you'd have to go into the Go internals to see this, but if it's bigger, it makes a new one, right? Or at least it adds on to that because it has to reallocate memory, period. So it has to build it for that in that case, and it just duplicates it over. But It's important though, if you're making a copy of the slice, so let's say you just want like a substring of that slice, you want like 3 elements of it or something like that. It will not, if as long as the underlying array is still being referred to by a slice, even if the slice that was originally referring to it gets out of scope and goes away, then the slice that's looking at it will keep that array alive. Yes. And so you just need to be aware of that, right? So most people, this is not a problem. When you add to a slice, no, because when you append to a slice like that, it deletes the previous one. Yeah. It makes a new one unless that, yeah. If it's appending to it, it's saying, hey, you want a new one out of this. So that one that was pointed to before, it's going to be there. We're going to make a bigger one, but it's got the same pointer reference somehow. I don't know. I don't know how it does it internally, but I do know this. The one thing you want to get carried away with, strings are immutable, string equals array, and then slices. I don't know about that. So the one thing to keep in mind though is that if you assign one slice to equal a sub range of another slice, that reference will keep the underlying array alive that the other slice is pointing to. I know that because I ran into that before. So let's say you have like a big ass, array list and you only want 2 things out of it. I mean, a slice, and you grab those 2 things out of the slice, but you grab a range. So you want to make a slice that's pointing to the other slice. I don't think it makes a new slice with only 2 things in that. I don't think it keeps the entire underlying array alive. So if you want to do that, you need to make a slice individually and then populate that slice from the other one so you can dereference the big one, and so the memory will get cleaned up. And this is what Rust people love to harp on, because those kind of conveniences that are taken care of for you behind the scenes are, by Go, are things you have to explicitly do by Rust and other things. How many pointers are left? Yeah, right. And most garbage collection does, pointer dereferences and stuff like that. That is not a beginner topic, but if you're a beginner, the takeaway here is use slices and just don't worry, right? Unless you're trying to take a few pieces out of a really big slice, in which case you want to be really sure that you're freeing your memory. And that's not something that beginners would be profiling anyway, usually. Python has the same problem. I mean, all the other languages have the same problem here. So it just so happens. And the reason Go does that, by the way, is for efficiency, because it's more efficient to write off that memory and just point to memory that already exists than it is to reallocate the memory every time for everything that's going to point to any element in the slice. And so that abstraction actually makes Go wicked fast for this kind of stuff. It just out of the box. So that, I think that's enough on slices. Okay, so let's talk about flags, and let's set our Pomo timer. Pomo start. Let's talk about flags. So what are flags? Flags are the things that you add to a program, and we're going to actually make a new program. We're going to say goodnight to this one. We're going to move args here, and we're going to make a new one here. Okay, so we can close this window down, make a new window, and we do not have a challenge for flags because these are based on Python, and that's not something that I would ever do with beginners usually. But we've already covered a lot more deeper topics that beginners would ever know about in this boost, including, slices and arrays like we just did. So, and the overall focus of Go here is to create really wicked command line utilities to do all kinds of things. And not knowing how to do flags is kind of going to be a hindrance. So we're going to do some flags. All right. So use the flags package. And I'm just going to go through it. I don't have a project prepared for this. This kind of came up during conversation today, and I do feel it's important enough to go over, but why is that yellow? Oh, that's weird. I don't know. We'll figure it out. Okay, so it should not be yellow. We'll just say about flag. Why is it yellow? It's driving me crazy. It should not be yellow. I don't know why it is. Okay, I gotta get over it. Okay. So anyway, let's make another one. Make directory, flag, fake flags, cd flags. And let's go ahead and make a new project here. In this case, I mean, there's so many different ways to do this. I don't have a set way to just show you how to do it. Let's actually, first of all, you can use args for this, right? So let's actually do that first. So you can use this, by the way, go install cmd args, right? So now we have args, okay? So now we can use args to do things. So we can say args space something here, and we get our thing. That's the reason we made it. But what if we wanted to say, I want to do -v for stuff? All right. Now, this is where I have to do mandatory rant against getopt. Okay, so, and flags use the kill covers. Yes. All right. So I don't know how to start this. So someone limit me on my time. I only want to spend 8 minutes on this, but I need to have a rant about this. All right. We've been spending 20 weeks with the Linux command line. And let me ask you, what is the easier thing to use here? Let me give an example. So I've been using Ansible recently, right? So let's do Ansible-H. That's a flag, sometimes called a switch. Some people call them options. I call it a flag or a switch. Okay, so you run this thing and you get this output that shows you how to use this tool. Now, if you look at that tool, I mean, it's using what's called standard getopt notation, right? This is something in Bash, and if you want to read about it, you can do man getopt, and you can read all about it. And this has permeated the world since the 1970s. It has been, in my opinion, a bane in our existence since the dawn of time. We do not know where the dashes go. We do not know whether there's one dash. We do not know whether there's supposed to be an equal sign for something that has a value or a space. It's just painful. It's painful. It's absolutely the antithesis of good user design. And for me to say that is heresy in the world today. And the devil made it get up. To say this, let me give you a worse example. Look at the GPG man page. I had to write an entire Perl module just to make simple all of the possible variations on this thing. And if you're asking me, could this have been done easier? The answer is undoubtedly, absolutely. So we live in a time when, and thank God things are changing. And if you could look at the Debian project, for example, they've already changed a bunch of this stuff. If you look at Netplan, for example, Git, you see a movement away from this in mass this year. And I'm getting kind of a spoiler alert, but I've created my own solution called bonzai, which has no dashes. So getopt has become everybody's bane of their existence. I'm still scrolling. I'm not even done through the GitHub. We're still going through options on GPG. All right. The GitHub CLI. Right. Yeah. There's another good idea, right? Because it's a modern user interaction thing, but not this. I'm still scrolling. And this is GPG, and we're still not to the end. Do you think anybody have you ever seen a command line with this stuff on it? It's wrong. It's just so wrong on so many levels, but this has become the standard that everybody uses. And what it does, I am still scrolling. Okay. We are on line 1,353 and I am still scrolling through GPG. This is the worst monster of options you could ever possible imagine. OpenSSL is even worse. Okay. These things are designed with unlimited ability to write as many options. I'm still scrolling. 2,000. Are we going to make it to 2,000? Okay, how many minutes? I've got 3 more minutes on my rant. Look at this. I'm still not done scrolling. 2,000 lines later. We're still scrolling, people. Do you think anybody actually knows that stuff? No. You know how hard it is to remember the one you have to have? I am still going 3,000. Oh, hey, look, finally some examples at the end. They don't. They don't need to. They just do because they over-engineer shit. The Unix world, and I am a member of the Unix and Linux world. We love to over-engineer shit that does not deserve this. Do you know what would have been better on all that? Because guess what all of those things actually are? They're hierarchies. They're hierarchies of commands, a complex domain language of recursive, sometimes pyramid of commands that you can get to, right? And they all start with GPG. And I made a tool to do that exact thing. I made something called bonzai because I was sick and tired of this approach. So with bonzai, I can put any of my commands in there. There's never a dash, ever. Because if you want to use a dash with an argument or something, it's usually something you want to add to a configuration variable or set before you even call it. So I can hit tab, and I get all the possibilities. If I want to sit, okay, well, what are my commands under unique? Tab. Now I get all of the possible unique commands. So I literally have, almost 100, and I'm going to have more than that, commands that are all embedded into a single command that have no dashes whatsoever. And every one of these is documented, right? So if I put help afterwards, I get full man page help built into the binary. Bonzai is probably my proudest creation, and we will probably do a little building with it here, but I want to first cover the standard ways that exist to do this. What about cases like OJSON? Then you just change the state. You change the state. You usually don't need an option. Usually what you need is multiple calls, and you want to be able to change the state up front. And the reason this is a problem is because everybody thinks they have to stuff everything into a single fucking line. And you don't. You can actually have state. And so built into the program is a modular. And by the way, here's where it gets even better. So when you want to import, you do. So this is my monolith, and I'm just going to go through bonzai really quick. We're not going to cover it right now. So bonzai, you can modularly import any bonzai tree command tree by just importing it. That's it. You import it, it's automatically there. Somebody else makes one, you want theirs, import it into your monolith. Boom. One line in your input, in your import. You get all of it. You get the documentation, you get the stuff that goes with it. And here's set flags. We're going to talk about that. So I know I'm not supposed to swear. I'm sorry, Shelby, but I get emotional about this one. All right. So here we go. So right here we have, it has all the documentation inside of it. It has all the commands in the order. And then you can do shortcuts. We'll maybe do one of these, but I don't want to do it right away. You can put the documentation in there. And then, Z tab, and you can say, I want that. I want a unique. What else do I got? I want an isonoun. Okay. Isonoun. Boom. I got an isonoun. What if I want an isosec? Okay. I can make if it's too many things to type, I can make shortcuts that go all the way to isosec, and they can run them that way. That's how I'm running my zpomo command. And this is my vision of the world. If you have something that needs state, you can do zconf, which I won't do because it stores tokens and stuff in there, and it saves them in the standard location .config for your Z monolith within your home directory. Because a lot of those things like -o.json and stuff are stateful things, and kubectl does this already. There's a number of other commands if you enter the world of tech right now in Cloud Native that are already doing this. So kubectl, right? So kconfig get contexts, right? So you have your context here, and what you do, so namespace is something you would have to type -n namespace every time. So instead of doing that, kubectl has come around and they've said, look, we need to change the state of this session so that every command after that point is referring to something. Same thing with environment variables, right? So my bonzai thing does environment variables without that. Cubans does the same thing. They're all doing the same thing, right? Git is the same thing. Git tab, git, right? So the idea of a monolith that subdivides all of these commands into a top level command, which some would argue is not Unixy because it's not, one best thing. But in 2022, yeah, Docker does it. So modern commands are doing this. Netplan, tab, same thing. This is the modern way to do things. The modern way to do things is to put a monolith and then put a bunch of subcommands in that. And then if you're going to use options, isolate them to those things. But in my case, I even further isolate it so you can have even more. So there's even no dashes. If you want to put dashes in, you can, but it's not something that you become dependent on. Okay. So I actually really struggled with this part of the boost, deciding how to plan it, because I am, and here's the kicker, I am ethically opposed to getopt. I think promoting the use of getopt is bad for the universe and humanity. And Chris Nova and people joke with me about that. They just think I'm silly for saying so. But I think getopt is bad. I think it's bad. I don't think anybody should ever use it anymore. And I think we just need to let it die with, the boomers who invented it. It's really horrible to say, but I really, really, really hate it. I have used getopt and been confused by dashes and parameters, and not to mention the fact that Go has decided to thumb its nose at all of it and just say dash version, which is like completely unheard of. Wait, not dash version. There's something else, right? Go has some of them, but there's a couple of them that just have a single dash, right? And so they don't even follow getopt, and so you can't remember. Does it have two dashes? Does it have one? Does it need an equal sign like pandoc? Does it need an equal sign? And so I have lived through this hell for my entire life as a professional, and I want it to die. I want it to die the death it deserves. I use it in Ansible all the time. I think that it could be done better, but it takes a fundamental change in thinking. You have to start thinking about stuff. Help is always, in my particular case, help is always a built-in verb. It's never assumed. You can do it, but like Z help is always an assumed reserved verb in my world. And that, yes, people complain, well, what if there was something else and help was a valid argument or something? Well, then that's up to you to make that granular enough into, some area, right? You could say, so there's actually help. If you want to get help, I'm being repressed. There's help on help, right? So my system also, help, by the way, is an optional module. It's not forced on you, but if you want it, you can use it. You can use Z help version, and it'll give you just the version. It'll give you just the version number. Z has no version, or the contact name, and it'll give you that stuff like that. I have bash aliases of dash help to help. Really? So, and by the way, in bonzai, you can add a command that is dash something. I've done that because so many people expect dash Z help to be there. So I actually made an alias. Dash H is a built-in hidden alias for the help command, which you can then put in that. So it's something called the Fluent API because it reads naturally. Is it called the Fluent API? Roasted function. I love that. Yeah. And yeah, because so many people use dash H, so that's been in there for a while. That was actually a request too from work. If you dash help will not do it. Dash help, I think, is there. Yeah. Dash help or dash H are built in and supported because so many people need those things, right? So, but then you get man page. This is not a man page, by the way. This is generated source. It actually truncates and wraps lines and all that stuff using many of the modules that are out there. And you can go look at that if you want to. That's bonzai. I'm debating about whether or not, as I said, to teach you flags or to teach you bonzai, and definitely not to teach you Cobra. So all of the cloud native world uses something called Cobra, which I think is an abysmal mistake that's been thrust upon humanity. Steve Francia, who made it, is a wonderful human being. He's now I think the head of Go evangelism at Google. He's a big deal now, and he also originally made Hugo and some stuff. Great dude, and horrible package. I hate it. I hate Cobra. I absolutely detest it. It's just perpetuating the same problem that is over and over. It doesn't. At one point, there were 36,000 lines of bash code in order to source to do tab completion. It's just so bad, and it just keeps getting perpetuated. It's become the standard for command line operations. People could use, the flag package instead of Cobra. And we maybe will use something there. But honestly, I want to promote at least people understanding bonzai so they can at least attempt a fluent API or what did you call it? A fluent interface that humans can understand. By the way, guess what other programs do? IP. There's one. You want to get your IP? IPA, right? IPA. So it's all about the fluent command line API these days. And I honestly I'm on the verge of not even teaching you flags because I feel like if you do, you're going to use flags and I'm going to be a bad person. In fact, I've just made a decision. If you want to learn flags, go someplace else because I'm not going to teach it to you. If you want to learn how to make the world worse by forcing people to use dashes and shit, sorry, I'm not supposed to swear. That's fine. Do it on your own time. So I am not doing flags. Are you going to, what are you talking about? Flags are misunderstood. Look, I'm not going to do it. I've just decided I'm not going to do it. I'm not going to do flags. Yeah, I'm not going to do it. Yeah, I'm just going to say, why I am not, uh, why I am not doing anything with GetUp because it's a waste of my time and it's distracting from the universe that I want to live in. If you want to build that crap, go for it. And I don't. Okay, I will cover bonzai, however, at the end. We're not ready for bonzai yet, but we will cover it. And that's all I got to say about that. Doing everything in employability first? No, it does not. No, you don't have to make code that uses Cobra. No, bonzai is used inside of Red Hat right now. So, yeah, you can. There's, if you don't do flags, are you a real patriot? No, the nmap when soon, very soon. Yeah, I have no idea how hard it is not for me to make a bonzai modular tree for everything that I want to turn into a busybox, clone. And so I'm going to do that. What about bonzai? We'll get there. There. I mean, you guys asked the question, and I'm glad you let me rant about it because I've talked myself. I cannot, in good faith, teach you getopt. I just can't do it. I despise it from like the deepest inner bowels of my root chakra. I just absolutely hate it. And if you're gonna do it, don't tell me that you're gonna do it, because by association, I'll hate you. I'm not gonna hate you, but it just gets me. I know it's like such a silly thing to get upset about, but I do. I get so bent out of shape about it because really simple interfaces are unnecessarily complicated, and I use them every day. The last tool I made uses no dashes, and the best tool you ever made. See, now, if we can influence the world to be a better place, and by the way, this isn't just me. There are a bunch of people that came at this independently, and I keep discovering other people who have done it. You guys showed me some. The IP tool, the Debian team, the Git team, the kubectl team. They're all coming to the same conclusion that the age of getopt is over. The age of, fluid APIs is the future. And I want to go there. It can hate something so much. Hate is a tough word to use there, right? App versus Pac-Man. Oh my gosh. Absolutely. I mean, there's a few dashes in apt, but you're kind of like, okay, I just detest the idea that not teaching the wrong thing will make things all right. If you don't teach the failings, people will repeat this stuff. Well, I just did, right? I detest the idea that not teaching the wrong thing will make things all right. It will if I teach a right thing. Why would I teach the wrong thing? I don't teach people how to code in Java or Fortran either. I have to make a decision about what I want to put out into the world. So go learn it. If you want to learn flags or getups, go read about it. It's not hard. Anyway, so that was way more time than I want to spend on that. But I feel I'm glad we talked that through. And it's all live for everybody to see out there. They can all, make their judgments about me. But so many people, there is a certain percentage of people that will see me rant about that and just shake their head and go like, oh my God, this guy. And so let's actually go back to our challenges that are kind of on the list to do. And they're fun and they're, beginner based and we're going to pretend like we never had to go down that rabbit hole. We will do a bonzai command at the end. And that's what Zet was going to be, by the way. We were going to build our own Zettelkasten command, and I don't know if we're going to have time. But let's go get on to some of the other fun stuff to do. Okay? So, and I'm not doing this. I'm not doing this. Sorry, flags. You can go someplace else. I mean, I've spent a significant portion of my life building bonsai, and I would rather people learn to use that. And well, bonsai is not used in the industry. I'm like, oh yeah, because it's used at Red Hat. It's used at a huge company that I work at for every major tool that we use, and a bunch of others. That's all so far. When you do 3 days a week, in weeks in a day, yeah, we're gonna try. I mean, these aren't necessarily weeks, by the way. So, so yeah, they're kind of hours. So we did args, and that's really all you need to know, right? And normally bonsai would come right there, but let's do 8-ball. 8-ball is fun, and then we can be back in the happy space. Uh, Inside the hill sector, I made sure of that. It's even used in the Norwegian sector. Oh my goodness! Thank you for saying that. Makes me happy. That's good that you know how to do it. We need to make a guidebook on it. We need to write a guidebook on how you can get started using it really quickly. And I don't want to do official publications for another. I want to let it simmer for yet another 6 months, so there's nothing really bad that we've forgotten out of it, But we've been simmering on it for about a year and a half now in alpha, and not really alpha, it's really beta. So I think it's really ready for like really pushing in a conference and making a talk about it or something, because I'm gonna make tons of enemies when I give that talk, including Frank, or Steve, who's apparently a really good guy. I've never met him. Steve, if you're watching right now, this is nothing against you. I hate getopt, right? So, doing Nordic. Okay, get yourself a talk at Gopher. I know, but we're not quite ready for it yet. I want to do the GopherCon talk on bonsai after we have significant examples of it being used. We have a guidebook, a digital free guidebook that they can follow to make one, and we've tested the crap out of it in the enterprise, because I don't want people to run into problems like after we do the GopherCon talk. TEDx, I don't know about that one. Anyway, so Args, 8-ball, and let's make an 8-ball. Now I'm missing my break because I didn't really get up. Do you guys mind if I take a quick break for like 2 minutes and reset? Would you mind? How about 4 minutes? I'm gonna take a break. Ready, go. Pause. All right, so we're back. I've got my coffee, and we've had a lot of stuff. You always manage to pull a better solution. I do. You know what? Don't get mad. Get busy. Don't get mad, my friends. Get busy. Make something better. If it makes you mad, spend all that energy. Don't go off on it. Sometimes you kind of have to, but to understand what's wrong, and then after you understand what's wrong, then get with your friends and make something better. Make the world a better place. Oh, I don't know. Stream education on Twitch because education in the world sucks. Do something better. Find some way to make the world better, and don't get mad. Get busy. All right. Now, speaking of getting busy, let's make 8-ball. So 8-ball is a really fun program that's near and dear to my heart. And I'm going to show you a video on YouTube that I'm going to have to block from YouTube because it's going to automatically give me a problem. So having said that, I'm going to pause the YouTube video. But if you want to go watch the video for yourself, it's a silly video. But as I said, I want to appeal to the 9-year-olds more. So 8-ball... 8-ball film. So there's a guy who made a film about the 8-ball, Magic 8-ball, a short film by AJ Tuck. No, this is a different one. A lot of people have actually made this movie about the 8-ball because I think it's a project, and you can find. Oh, that's a scary one. You can find a lot of them. I'm wondering if I can actually find it again. It might actually gotten buried behind the 8-ball. That's not it. That's not it. Yeah, I have to go. I might not be able to find it now. This was years ago that I used to use this as a prop to go do. If you don't know what it is, so let's do. That might find it. No, it's not. The Mysteries of the 8-ball. No, it's not there. I'm not going to be able to do it. You're all going to have to go find your own. Hopefully it's suitable for work. Oh gosh. Okay, so much for that. How's it going, Hart? I'm not gonna say your name. I'm sorry. We gotta not have you talk for a while. Because of your name. So anyway, let's go to let's go to, anyway, just search for 8-ball game. And if you're looking for a fun thing to do, this is a great game to make. Magic 8-ball. 8-ball is also the name of a drug, so I know you gotta watch out for that. There's the Magic 8-ball. You get horoscopes from it. It has standard answers you can go to. There is kind of a funny video, but I can't find it now. It looks like it's been taken down probably. The official app. But if you know the game, it gives you a random answer when you shake it, right? And then that's it. That's all I want to say. And you can actually look up the actual answers if you want to. If you want to find them on Wikipedia. And we're gonna, but it's more fun when you get to change on the answers, and instead of doing videos. Let's go to Magic 8-ball. So here it is, and then we've done this as a game. You can do this as a graphic game project, or you can just, here's all the answers here. You can go put those in. Okay, so let's actually make this. So this is the project. We're gonna make a program. This is the same thing. You can do it in Twitch actually, or in IRC, right? In IRC you can just type 8-ball, or you can have a plugin. I actually think we might have one through CloudBot. Let me check. Is it not there? What's up? I don't think it is there. Oh, it is there. It depends on Doris. Oh my gosh. Who did that one? So 8-ball. What is, let's see, you have to ask answer no questions. Will we finish on time today? And it's like it should answer. It might be too fast. Yeah, I think it's like only one every like 10 or 20 seconds or something. But we're gonna make something like this. No, but we're gonna make it in a modular way so that you can actually take the functions and test them, and then put those in something else when you want to make like a Discord bot later. Okay. And 8-ball, what's up? Sure. Yeah, I think I changed all those. Those are, yeah, it's from a while ago. Anyway, let's write it. It's pretty easy to write, but I think this will give you a sense of it. So we're going to do another project, make dir. At this moment, I would have you, I think about what you have to do to make a project called 8-ball that's going to be a command that's also going to have a package library in it that you're going to reuse in other code. So what are the steps? Somebody want to tell me what they are? Well, you should already know them, right? You should be able to spit them out like anytime. What is the first thing I need to do to make a project? Make directory, and we'll call it the number 8, and then ball. All right. Create a directory. We cd into the directory, and then what do we do? Yep, go mod init, and then we're going to call it github.com rwxrob boost weeks 20 8-ball. And you really probably want to use the GitHub by default as the name. You can get away with example or whatever, but you probably want to do that because you probably will end up publishing at some point. Yeah, if you're gonna do a full new project, but you can actually have multiple commands. I mean, if you've already got a module and you want to put all this stuff under that module, you can do kind of like what we're doing here. So, and if you want to make a new GitHub command, yeah, you would do that. So here we've got go mod, right? We're ready to go. And I already know I'm going to have a command, so I'm going to make a directory called command, and I'm going to make another directory called command / 8-ball. By the way, how do I do those two commands in one? A little bit of a reference to old bash stuff we did. What is the switch? Hint dash something. Yep, there you go. You can use that too, or you can use -p. The -p, true or false? -p is POSIX compliant. Try that on SSH. You want to see? Want me to prove it to you? OpenSense. What's my password? Okay, I'm on BSD Unix now. You want to see on BSD Unix? I'm on BSD Unix. Which mkdir? Okay, make dir -p foobar. Uh-oh, it worked. It did it. It did it on BSD. I thought BSD would fail. It worked. So interesting. That's interesting. That's an interesting little tidbit I've just learned. So FreeBSD actually supports the non-POSIX compliant mixer now. Very interesting. Wait, I need to get out of here. I'm on my firewall right now. Don't worry, there's nothing there for you to see. Those are all public. Including my DHCP address, which I don't care if you have. Come at me, bro. It would be bad if I put reboot here because that would stop the stream. There's the one that says I haven't used this much. Where's the one that says log out? Oh, there it is. Yeah, okay. Anyway, so yeah, thank you. It also works in PowerShell. Interesting. Okay, good to know. So, right, we have a thing there, yeah. So let's go ahead and make our file there, main.go, and we'll use the default one that shows up here, and we'll print. Let's just print. Welcome to the Magic 8-ball, and 8-ball. Okay, so let's just start there. If you want to, you can just. I already have one, I think. 8-ball. Yeah. Whoopsie. Enter a yes or no question, and your answer will be granted. See, this is the actual finished product. Damn it! I wasn't going to show you this yet. Will we finish on time today? Damn. Random division by error. Okay, so that's actually a bash program. Yeah. Division by 0. And there's a problem in it. There's a problem in my 8-ball program. Yeah, we're going to have a conflict because I'm going to be doing one and go. Here's the bash one. So this is in my dot program, my dot files. Do you remember the escapes? Is B. So here's blue, declare art equals, and then it puts blue into that one. Oh, I got rid of them all. That's why. See, I got rid of all my answers, and I have an answers.txt, which I don't have anymore. Yeah, it's broken. But this is the bash 8-ball program. So this is exactly what we're doing, and we're gonna do it in Go. Okay. So if you want to just port that, you can do that. All right. It's fun. It's fun. All right. So it finished. It will be infinite. Yeah. What it did is I broke it because I can tell right before I got rid of it, I put all my answers in an answers.txt file instead of declaring answers here. Yeah. See, if I do this, if I uncomment these, you want me to fix it? I'll fix it. UMC with a filter, and that should actually work. 8-ball. Are you broken? Cannot predict now. Why not? Are you sick? You may rely on it, etc. Are we done yet? Ask again later. Okay, how about now? Yes, definitely. So, and you can type quit. Yes, definitely. Oh, you don't know quit? Oh, wait, Control C then. Anyway, that's the working email program. We're gonna make that a Go, and it's a little bit harder to Go. Now, it is nice to read it from a file, and we may actually do that as an opportunity to use YAML and JSON, which we haven't learned yet. So we're gonna start with our program. So go install, and I'm just gonna straight up install. It's gonna take over my other one though, because why? By the way, somebody want to tell me I have two programs named 8-ball. What is gonna happen? Which 8-ball is gonna run? See if you can predict. I'm going to show you my path. Which 8-ball program is going to run? No, not yours. Not yours. Wrong. Bzz. We'll have some dinner, Kentone. Thank you for signing up. Which one is going to run? So user local bin, user local games, or is it possible that I just got rid of my other program? Yeah, I don't know. Let's try. Which 8-ball? User local bin 8-ball. Watch this. Welcome to the Magic 8 Ball. My other 8 ball is dead. My other 8 ball is dead, my friends. That's right. I destroyed it. I destroyed my other 8 ball. I gotta go make sure I didn't really kill it. Because it's all in the same place. So, ls-l 8 ball. Oh, I guess not. Nope, that was the one that was there from before, from bash time. So yeah, I mean, I've got that one in source, so that's fine. But the point is that we have multiple 8 balls there. I mean, it's. I want to go see if. I want to go see if .local is linked to anything. Local bin. Oh. It didn't deserve to be timed out. Your name is if that's your actual name, I'm super sorry. There's no way I can confirm that at all. So, so yeah. Okay, cool. I'm sorry. I'm so sorry. Okay, so user local bin, and what is that? User local bin, user dash L. No, let's do dash. Yeah, let's just use user local on this. On the bin, let's do dash LD, and we see that that is not a home directory. So that actually got copied over. So that's good. And we can we can go do all that other stuff. Okie dokie. So we have a number of other things in here as well. Revive ZMQ. Yeah, I don't know if we're gonna go through all that. So the high program. Okay, let's just keep going. I don't, but just make sure if you you've set your go bin properly. We covered that already. Okay, so okay, so yeah, we're gonna do install 8 ball command. Yeah. All right. So we got it. We got our thing. 8 ball. We got our new one. And then what? Welcome to the Magic 8 Ball. Well, we need to do a lot more. So what should we do here? Now, this is one of those cases where an example test case, this one doesn't really lend itself well to testing. Because why? Because I can't actually interactively test all the possible things, right? But I can break out the functionality that can be tested into something else. So what are the things? Let's just thinking about it. Like, what are the things that we're going to need to do with this? Right? So what if we created a function that does the same thing as the 8 ball, right? Without having it be command, which is the highest level command that we're going to do. We need to make a list, right? So let's make a library that does all of it. So let's say, let's make a list of strings, and the first thing we'll do is we'll say, okay, we're going to say 8 ball, and we don't care if this is an exported thing. So we're going to 8 ball let go, and we're going to change this. We're going to make this 8 ball. I don't actually know if you can have a package name 8 ball with a beginning number. We're going to find out real fast. We're going to find out real fast. Yep. Yeah, you can't. So we're going to have 8 ball. We're not going to be able to have a package named 8 ball at all. We can have a command named 8 ball, but we can't have a. That's interesting. Yeah, it didn't mind the command name, but it definitely minded the other stuff. So I'm going to move this 8 ball to 8 ball. And yeah, and you could call it Guru or something. 8. I don't know about that. Move 8 ball to 8 ball. And we're going to move CMD. I mean, we can leave the CMD 8 ball in there because that's a command. This is going into YouTube, so tone it down a notch. I mean, he said to himself as well. So anyway, so we have this command we know we're going to be calling, and then we have this thing here. So I'm 8 ball let go, of course. And let's do that. So we have a package 8 ball. And we can actually now go through our test-driven kind of thing. And the problem here is that we have no way to know what the possible answer is going to be, right? So it's very hard to test this. And this is actually an opportunity for fuzz testing that I would really like to get into, but I don't understand how to do yet. Which lets you print any number of variables and see if they work. You know, it has to be one of the following sort of things, right? So this is one of those cases where a test case is not going to really help us much, because what are you going to test? You're going to call that it's going to be a random answer every time. How are you going to test that consistently? And people do, in order to pass unit test requirements and get coverage for no reason, that just check that the answer is not empty. It's not an empty string, which is really stupid because it's not a test at all. It's just a waste of time in order to get a percentage number on test coverage. So in this particular case, I think we're going to actually skip the test for this. So we're going to say func, and we could say 8ball dot ask. Let's say ask 8ball dot ask. So ask, and we'll document it. So ask will return, actually, let's see. You know, you can get really crazy with this. You could say ask will save the question asked and provide a response, you know. And see the generator? No, because I mean, you could. It is a seeded generator. You can make sure the seeds are the same for both. Yeah, you could definitely do that. But, and we're going to get into that. We haven't done that yet. That's a little bit harder later on. It's actually a hard part about Go as the first language, because seeding random numbers is not beginner material usually. So we can actually say 8ball respond. Okay, how about let's say that respond will return a random response from list of responses. Okay, so there you go. So we're going to need a response. We'll make that a string. And we'll say, we actually don't need, look at that. We don't even need an input argument, right? And we could get crazy and say mood is like positive or something, but you know, no. So here we're just going to make a constant list of responses. And for this, we're going to just responses, and these will show up in the documentation. Responses, oopsie, equals, and that's the only one. So we can just put it here, and we make it a list of strings, and we're going to put them all in here. So you might not have seen this before, but what this says is make a string and then give me a bunch of them, right? So now we can put them. They always have to have commas after them, even if it's the last one. And that's a Go thing that I love that people hate. So we're just going to say yes, no, maybe so. Yes, no, maybe for now. And you can go in and finish that more yourself. 24 OS threads. What? Nice. So here we have responses, right? So we need to respond from one of those. So we need to pick one. Pick a response. And how do we do that? So we need to get a random number. And this is an interesting opportunity for you to actually we might do it later. We'll take out stuff that you could reuse and put it into another library that you could just import anywhere, right? So there is no random. If you remember the stuff from Bash days, there is no random, right? There's only, you know, if we wanted to, we could actually make another function for this. So we could say func. First of all, let's just return responses, and they're already predefined. So we can say responses, and then we'll say we get to pick a random number between some number and some number, right? Now Python, this is super easy because it's built in, right? And there's no such thing in Go. The last I checked, there wasn't anyway. So let's say picking a random number in Golang. There might be something new in 1.18 or 19 that I don't know about yet. We're probably going to have to write our own routine like we always have to do. So this is the standard way. I've seen this a million times. So rand int, generating a random integer, the entity function of the rand package can be used to generate an integer in the interval from 0 to n. Oh, that's cool. They did not used to have that. Did they always have that? How long has that been around? 0 to n. Let's do that. Let's see, integer in the interval of 0 and n. That means it's not going to reach n. The n or the upper bound. Upper bound is not inclusive. So we should be able to do rand.int actually. God, I hope so. And we could just say 3 for now, but we'll fix this, make it sharper later. And okay, so this is something we can test, right? Random.randint in Python. It's like that. It is, but I don't think the randomness has been seeded yet, so I think it might fail on us. I hope they fix that. That was kind of an annoyance before. So wait, where are we? 8ball. Go tr. All right, now that's something we can test, right? If we want to just make it run, I mean, I wanted to get it to run without making a whole program. So 8ball test.go. I'm going to use an example test. I don't know if we need an example test here, but we can. So test func example. What do we have? Respond. And if nothing more, this will call it and we can see it output. The output's going to be, random, but well, we can do some tests for that. So fmt println. Actually, let's do this. Let's say response equals 8ball dot respond, and that should give it to us. Now it is using the built-in constant, so it is not completely autonomous, functional kind of thing. It is pulling in state, which is the constants. I mean, we could make another function that returns a random element from an array. I think that actually exists. Python has that as well. No, I don't think so. So let's try it. So it says 8ball response. Let's see. My type string is not constant. Not enough arguments to call to rand int. All right, so let's fix that. Rand int cryptorand. Oh, we need the lower bound, of course. So actually, this should be 0, 1, 2. Yeah, so that's fine. It says undefined 8ball. What do we? Is it still with the 8 in it? Oops. No, it should be there. Huh. Let's see. What's up with that one? For some reason, it didn't install it. Maybe it's because we haven't gone installing yet. No, it's not going to install it yet. There's a problem here. Obviously. It doesn't. I might have to actually forcibly import it and having my editor grab it automatically. We'll see. Import. Oh God, I don't want to have to type it all though. It's in my go.mod. So my editor probably throws. Oh, look at that. That's why. That was the problem right there. Okay, I fixed it. I found it by doing it. I forgot to change my go mod because we changed the name. That is the authoritative name. So now when I edit the test, it should find it. Save. There we go. Okay, so and that should actually fix the test. All right, value of type string is not constant. 8ball go lang find. So this is errors. What are these errors? I don't know. 19.5 line 5. Here we go. Oh. I don't think I can use a slice. Yeah, I'd have to use an array for this. I think I can do this though. Is not constant. You telling me arrays are not constant? All right, fine. Well, make it a var then. Random value type big int. Single value constant. So that's an array. If you want to, I mean, slice is fine too. That can actually be modified. 0 in single value context, int 03, value of type big int in single value context. Oh, is it returning an error as well? Oh, it does return an error. Okay, so we have to do this. We have to say like I comma error rand dot int. This is kind of annoying, no doubt. And then we say this. I have a macro for this. If it equals nil, return error. Actually, I mean, this is weird. Wait, let's actually not return it. Let's log it. So, because it'll be the first one. Yeah, let's actually log the error. Log dot print ln error and return. So that will return an empty string. My brain hurts. How about that? And this can change to I. Boost. Cannot use 0 constant type instance for IO reader. Int does not implement IO reader. Huh. What am I doing wrong? Big int value in arg to rand int. Oh. Good old typing. We're going to have to like type this. Yeah. Constant of type int. As type IO reader in argument to rand int. I am missing something here. Is it rand int n? Why does that have an IO reader? IO returns a uniform random value from 0 to max. It panics. I wonder what int does. I wonder why it takes an IO reader. That must be the random device. Yeah, I don't know. I'm reminding myself of all of these. Been a long time. So int n only takes one. Does it take it reads the randomness from it? Nice. So int n is a little bit simpler. Nice. Thanks for finding that. So this is the upper bound, right? There isn't an int n. All right, let's read the docs. Go doc rand. Crypto rand, right? Are we using crypto rand or rand? We're using crypto rand. I guess I put it in there. This is pseudo, so don't use this for anything important. It doesn't return an error. There's int n. It gives you an integer, returns an int. Nice. That's new. When did they add that? Usually it will tell you, actually. If you like look it up, it will tell you when it was added to the language. If you look at it in the other docs. Oh, look at this. This is interval notation, people. I love this. First time I thought that, I thought somebody made a mistake. This is interval notation. This means, the bracket means inclusive, and the parentheses mean exclusive. That means that if you may set it to 3, it'll be up to but not including the number 3. So this is interval notation. You'll see this in coding all the time. It's a math thing, but it's important that you know it. So, yeah, I see it now. Let's go there. That you love watching me suffer. I know you do. Okay, so let's go back here. We'll do int. I mean, at that point, I don't even really need this in here. I can do this. Right, much simpler. Much, much simpler. It's in crypto rand. What the hell? What am I missing? Rand. Oh, go doc. It's weird. Oh. I have rand there. Huh. It's not crypto rand? Are you sure? Because look. There it is. Crypto. Oh, it said use the crypto rand package. Oh, gotcha. Gotcha. Yeah, that got me. It made a guess and it was wrong. All right, this is the pseudo random. All right, that's good. It's not going. What the hell? Oh, it's math round. It's math round, right? Oh, yeah, you just typed it. It's math round. Okay, gotcha. Yeah, so crypto rand is cryptographically sound. Math round is random and fast and happy. And that goes, by the way, for every language. They always have the two different ones. And they use, be careful. We talked about that when we were doing randomness earlier. Respect response declare but not use. Okay, that's in our test. Yeah, so we can actually just do something stupid. Println. Response greater than 0. Or we can actually, I sometimes do this because I want to see it. Which you can also do with .log if you're doing the testing framework instead of the example test. So you want to see the output, but you don't want it to be a thing, right? So got true. Yeah, I mean, if it would be 0, it would be an error if we got a problem. And every time I run it, it should get a different one. It seems to be getting maybe a lot lately. That's because it hasn't been seeded every time. Yeah, it's the same seed. That's okay. So this is, I remember this from years ago. We have to seed it every time. So it's not good enough to just call it. You have to seed it. If you don't seed it, you're going to get tripped up. This is a big, with see and go, this is a problem. It's always picking 3 for some reason, right? Because it's only, you have to reseed the randomness every time. Was for math round? Was it really? I missed that. Okay, I thought it was the other one. So as you can see, it's doing the same. That's not very random, right? So obviously that's not going to be enough. And we need to change that, right? So what we have to do is we have to seed this, and that's what was covered in this part right here. It's actually in this link file right here. You need to do this. It's probably good to just go look it up. I can't ever remember. I have to always look it up. But there it is. This magic line. So this, we'll talk about it. But what this, anybody ever play Minecraft? We have any Minecrafters here? What happens if you set a different seed in a Minecraft world when you make a new one? Right? Still doing it, but I don't know if we'll figure it out. You set a seed, right? And the entire world with that seed is generated in exactly the same random way. Isn't that cool? I really love that. I really love that. Every single, every seed gives the same world. And that's because of the pseudo-randomness. Yes, it's random, but the pattern of randomness is guaranteed to be the same every time based on the seed. So even though it kept giving us maybe every time, it was giving us the same random response for the same seed every time. And so it wasn't randomizing it. So if you wanted to randomize, to reset the seed so you get something new and random every time, then you need to do rand.seed, and you set that to some extremely random, in this case it's predictable even more, but you set it to some value that's different, right? And so every number, every value that's passed in this seed will always produce exactly the same numbers in the same order. It's pretty damn cool. So if you wanted to make a Minecraft world generator that was random, every world was random, but the randomness was dictated by the seed, this is how you can do it. And it's just kind of cool, but it's easy to miss. And I don't know if you see, but every time I run it now, the log line is different, right? So it's not a very high percentage difference, but it's definitely different. We haven't got any no's yet. Let's make sure we can get a no. Yeah, we got a no. Okay. So as you can see, it reseeds every time, so it re-gives us another true random number. Now, if you wanted to put that into, you know, a thing, you could. There's something else we can do here too. What can we replace the 3 with? Hash functions to checksums, etc. Yeah. Yep. And so that's a good point. So how do we change the 3? What if I do this? Yes, no, maybe, never. Is it ever going to get never? Yeah, right. Good one. So it's never going to get it, right? So we're going to do len of responses now. And you can probably get this, right? You get this on your own. So now never is included. You know, it's included in the list. And there we go. The rest is easy, right? So the rest is a matter of changing other stuff, right? So let's actually fix the test so it passes. So we want the test to say true, which is kind of stupid, but you know, it could be changed to an array. Yeah, it could be. And then it wouldn't be a dynamic. You wouldn't have to change it every time. Absolutely. You totally could do that. That's what I had it at before. Yep. Yep, because it's a fixed thing. It can't be a constant apparently. Which I thought it could be, but I guess not. I guess you can't have slices of constants. So, yeah, we can do this. If you do this, it turns it into an array instead of a slice, and that is guaranteed to never change the size. So that's more efficient. It puts it in the constant space in memory in the heap, I think. So we got yes, no, maybe, etc. So that's it. So we have a response, and the rest is just kind of flushing it out. I mean, we can do it. It's kind of like, here, close up, you know, for me, and hand somebody else the sutures. The rest of the stuff that's the hard part of this. The rest of it's just fun and easy, right? So, you know, you just need to I mean, the prompt, we did the prompt already. We did all of the prompting and stuff in the other challenges. So all of the stuff about prompting and standard input and standard output and reading control C interrupts, and we didn't capture an interrupt, but we did everything else, right? So that is all here. All the stuff about colors and printing stuff out. Let's actually add a constant since we haven't done constants yet. So here's a constant. Let's add art. Okay, we'll make that a constant. Const art equals, we'll make it a thing. And we can go out. There's like lots of ASCII art places you can go online and get stuff. You got to be careful. We're probably going to see some digital boobies here. I apologize, Twitch. I hope you don't ban me for it. There's definitely boobies here. So let's see if I can find them. Hopefully there's nothing worse than that. The demo scenes. There is actually, if you do ASCII art 8-ball, there's a ton of them out there. Yeah, there it is. Oh boy. These are kind of boring, but there's our 8-ball that we used in the last one. So you can copy that, copy, and paste that in. Wow, look at that fancy 8-ball, right? And this is having problems. Why? Because of this. We got to escape that one. Actually, you can't escape it. You got to get rid of it. You cannot, in this language, you can't. You could probably put a, well, that's good enough. That's good enough. All right, so, and now 8ball.go, and we can actually, okay, so now we have the whole respond prompt, right? But I mean, you can put the rest of the stuff in things too if you want. I mean, it's a tough question about whether to put it in the main program or to put it in a function, right? So, but let's go ahead and put it in the function. So we could say, oh God, what have I done? What have I done? All right, we got all done. So what are we doing? We're doing 8ball.go. Finish loading packages. Okay, we got that all in there. What else? We could say, let's do prompt. And we actually made a prompt command from one of our other things, right? So prompt, and so we're going to prompt for a string, and you can, you can document this if you want to. If you go properly, otherwise everything ends up in main and looks like spaghetti code. Probably true, yeah. So prompt prints the optional prompt. We'll just say by default, and returns the string entered by the user. All right, that's what we want. So return val, we'll call val a string, var val string. So that's actually valid right there. And we need to have an optional argument. Yeah. So let's have an optional argument. So we'll say args string. So that means it's optional. If they have an argument, great. If they don't, no problem. So then we say if the length, actually let's do this. Let's, instead of saying val string, we could say val equals this thing, right? And I mean, we'll put a mandatory space after that as well. So, but if the length of the args is greater than 0, and let's make actually no, we'll say prompt. We'll say p. How about that? P equals args v0, and that's the first in the slice. If it's there, overwrite it. Otherwise, use the other one. And then what are we going to return? We're gonna prompt for the value. So actually, the value is still a string. So var val string. That means it's an empty string. And we need to do the prompting. So we need to print it, right? So fmt println to print it to standard output. Actually, we're not going to do a println. Why? Because we don't want a line return. We want it to print and then have them type something in. So we can say we're going to print p. And if we did a printf, I mean, you know what? Let's keep it simple. Let's make it so it's a space by default. If maybe they don't want a space, so we'll let them have that control. And print. So it's gonna print it, and then it's gonna wait for them to type something in. And this is where color gets interesting. So we'll get to it in a bit. So then they can type something in. Now this is the weird part because we have to read from standard input. Now we wrote this already, if you'll remember, back in our other code. So if we go back several days, Git grep greet. So in our greet command, which is in week 18, we can go into week 18 and we look up our other code. And this whole reuse of code, I kind of want to go through that because eventually you're going to see that there's some things you kind of want to save to use because they're just convenient for you to use all over the place, right? Now we put some stuff in internal here. So we put this read line thing in internal and said nobody can use it, right? And we did this some time ago, and it was kind of, tough, if you remember. It always bothers me doing this in Go because this is a lot of code to process early in the process of learning. And so we're reading a line. This is reading one line of code, right? And it trims the space. So, but unfortunately, we can't reuse that because why? We can't reuse this read line because why? So we're going to do a little bit of refactoring here. I'm going to go through it because it makes sense to do it right now. Like, man, I wish I had that function anywhere, right? I wish I had that function. So what can we do? We can say, well, gosh, we're going to take a break and we're going to factor that code out so we can use it. Because right now I can't use it. Watch. In fact, I'll show you. So let's actually try to import it, right? I mean, wouldn't it be great? I could just import that other code I already wrote. But you can't do it. So I'm going to prove it. So we go to here, we go to GitHub, say this is the path. We want week 18 greet /internal. Okay. And where are we right now? Okay, here we go. So yeah, we want to use read line. In fact, it's kind of funny because it won't let us import it. So because it's in internal. And now normally when you're in, it'll do this for you automatically if it's importable, right? But no, see, I saved it. It's like, no, you cannot use that. But let's go down here and let's try to use it. So let's say greet.readline, and we'll say val equals readline, right? Save. Uh-oh. It says go greet get. Now it's actually not go greet. It's greet internal, right? So this is where it's going to get interesting. And it's going to be like undefined greet. There's no such thing as greet, right? Because we can't import internal. So we have an option. All right. We're going to break something here really quick. We have a couple options. We can stop making internal, and we can take that read line and, we can move it up out of there and then it would be part of the greet package. It would be greet.readline, right? Or we can just move the whole thing completely and make a new module. And why don't we do that? Okay. So let's do that. So I know this is a little bit confusing. We're working with three different projects right now. We're working with the Greet project from which we want to steal some code. We're working with the 8-ball project that we just want to read a line, but we don't want to cut and paste because that's yucky. We don't want to, repeat ourselves. So we're going to factor that code out. That's what it's called, factoring out. We're going to factor that code out into its own standalone module that doesn't have anything to do with any of the projects. All right, it's just a utility module. Although, don't name your modules util. Usually a bad idea, right? It's usually better to come up with a better name, a name that's more relevant. So in this particular case, let's make a new one. Let's make dir. We're going to call it term or CLI. How about that? Command line interface. So it's all the stuff related to CLI stuff that we want to use. So let's make a CLI package. This is not going to have a command in it at all, right? Same idea here. This is its own standalone module. It would be a separate Git repo if you wanted to do it that way. So go mod init github.com rwxrob boost weeks /20/CLI. All right. So now we got a new module and we can name the module. Let's just touch it. So let's name it CLI.go. And now we can steal that other code from the other project. So where is it? So we're going to open this code. So our internal over here we got doc.go, which you already know about, right? That's where we put our documentation. But you know what? let's move that whole thing. In fact, let's move this internal. We're breaking the greet program by doing this, and we're gonna have to fix that. It's called regression testing. Is when you refactor and you don't change any behavior, but you want to make sure stuff still works, right? So wait, where are we? Greet. Okay, so we're gonna move internal into temporarily, lol, and we're gonna move all that stuff out. So we're gonna say move /temp internal, all that stuff into here. And now we've got doc. We don't need doc. I mean, we could, but we'll need that later. So we have readline test, and we have cli.go. We really don't need this. We could just say package CLI and have it be empty. Okay. But we have to change the readline files to be CLI now, right? And then readline, vi readline underscore tests. We'll change this to CLI test, CLI underscore tests, and it's gonna, this is wrong now, right? So we're no longer doing that. Now we're in doing this one, which is boost weeks 20 CLI. Usually your paths will be a lot simpler than that because you'll be separate repos or something. 20 CLI, and there's no internal anymore. So, oh boy. And now we need example readline, and I need to change this internal to CLI.readline. And that should work. Now we can actually test it. Same test. We just run the go test again. Go test, and we pass. All of our tests pass, right? Now let's go. So now we have a working command line module we can reuse. So we need to regression test our greet stuff. So let's go back to that. Here's our greet stuff, right? So if we try to test this, it's going to fail, right? Go test. Like I have no, wait, why did that fail? What did that file? Oh, the command is going to fail. Maybe I don't have enough tests in here to test stuff. I don't know. I might have a problem. So yeah, look at that. I don't have enough testing going on in here. Nope. I need to do more testing because I just failed. Oh, readline. It's not, readline isn't in here at all. It's not in there at all. We must have put it in the main. All right. So this is going to fail then. So if we do go build, wait, go install ./cmd/greet. Uh-oh. It's like, I don't know about internal. So that's where the problem is. Okay. Greet main to go. And obviously we can't use this anymore, right? So we're not using greeting internal anymore. Now we're going to import another dependency, 20. What is it? Let's see. Boost weeks 20 CLI. CLI. And down here, instead of internal readline, we do CLI readline now. But, I mean, for better or worse, we now have an external dependency. Okay. And what I want to show you is when you have an external dependency, I want to show you what happens to the go mod file. Okay. So if I do go get dash u to update everything, there's no dependencies here, but sometimes go.mod. Nope, this was not showing it because this package doesn't have a dependency on it. I guess that's not a good example, but you'll start to get versions that'll be in there as well, and it'll show what versions it has a dependency on. But because it's a separate main command, I think that's the reason we're getting protected from that right now. So if we do go install cmd, this is our regression test, I guess, in this case. And nope. Okay, it's like I have no idea about the CLI thing. So go get github.com trub boost weeks, and you can 20/CLI, right? And it's like, I can't. Now, this is where I'm so glad this is happening because I get to show you about Go work now. So a lot of times when you're doing development, let me put this in my notes. Interval notation, factoring out commonly used code into own packages, library packages, modules. Okay. And go work using go-work go work to avoid package dep hassles. This is a big deal. This is actually one of the best reasons for 1.18 that ever exists. That's why I will never use anything besides it. Problems. And there's ways around it, other ways, but they become deprecated methods and you shouldn't do it. So we have a problem here because now we can't build because it has no idea where to get it. Why doesn't it know where to get it? There's two ways to fix this. One of them is to commit the code and so that the code appears in GitHub. We have created effectively, I know they're all in the same Git repo, right? They're all in the same Git repo, but as far as Go is concerned, it's as if we had a separate GitHub repo for a CLI because they're all modules within a single repo, which I didn't even know was possible until this. I mean, I had a hunch of it, but I never really tried it. Having multiple modules, anytime you have a go.mod, that's the top of a module, right? Is odd within a single GitHub repo. But as far as Go is concerned, this is the same as if we had multiple GitHub repos, each with its own module. And so when we have a module in so the CLI module, Weeks 20 CLI package library, which is, a module, there's a Go mod in there. It doesn't know about it. It doesn't know about it because the only thing Go knows about, and this is for safety reasons, is what has been committed to, the internet. And that's why, by the way, that we chose to use GitHub and stuff like that. You could certainly try to use example and get around that, but I don't want you to get in that habit because you'll end up getting problems later on when you try to move it into actual GitHub source or something. You want it to be in a place that Go knows to use to go fetch it, right? So right now, it doesn't know it exists because even though we made it, unless we commit all of the code we've done so far, it won't know where to resolve it. So it goes out to the up to the internet, and it's like, I don't see it. And here it says like Go module upgrade, right? It's like trying to find, it's looking for all of the, the numbers for this boost, but it doesn't see it because it's an old repo. So this is a very common problem. And until Go 1.18, you couldn't simultaneously work on a lot of packages together in kind of worker mode without some real convoluted crap. You would have to actually change and add a replace line in the go.mod file, and you'd have to pray to God that it didn't get committed because it would actually stop your work from if somebody else imported your replace line, it would break everything in their code. And so in Go 1.18, they introduced something called Go Work, and it's so amazing. The problem is you got to remember it's there. So I'm going to go through this today, and I wasn't planning on doing it, but this is a perfect time to do that. So we're going to do Go Work init as the first thing you do. And you do that from inside of a module. All right. So in this case, the module that has the dependency that's failing needs to be given a hint about, for the sake of our work, to go someplace else, right? So then you can look in the go.work file, and you can see that it's like, okay, 1.18. So far, it doesn't have anything in here, right? So, but we're going to do this. We're going to say go work use, and this is where things get crazy. We're going to say use ... and because we're assuming you're going to build from this directory. This is why it's very localized. And we're going to say what? We need to do it into the CLI, or is it week 20? So that's going to get us into, okay, we need to go one more up. Yeah, we need to go into 20/CLI. And now that will resolve that for us, right? So if you look at the go.work, it should work. Let's try it. So it says use that, right? So if you need a CLI, give that a shot. And I haven't done it with that many levels of directory, subdirectory. So this ought to be interesting. I've never done it to that depth. But anyway, and that the go work always has to be in go.mod. And by the way, you usually you don't want to commit a go.work to your tree. Because when you're doing building and stuff here, it will be ignored. But the next person who comes along, if they try to do their build and they don't have those things there, it'll break, right? So, I still think that you should use I mean, I have my own way of doing this. Other people have their own way probably, but I actually, I mean, somebody would probably tell you not to commit go.work. And I think that's probably a good idea. So I would actually add a getignore for this. So a getignore, I'm editing .getignore in the top of in the top of this, I mean, this directory, and I'm adding go.work because I don't want somebody else to be, I don't want their go.work to be blown away by my go.work, right? But if they want to have a go.work and turn it off, this is my own personal convention. Nobody does this as far as I know. It might not work in a team environment, but what I'll do is if I don't want go.work there, I'll move go.work to go.work.out. And then I'll commit that or out, or sorry, not out, off. And I actually have a tool that does this. I have a Z tool that does this for me automatically. So, and the reason I like that is because if somebody else wants to simulate the package dependencies that I have, they can use that. And that, because they get involved. You get quite a few entries in there when you have a lot of localized packages you're working on at the same time. So that might give somebody a hint. Maybe they don't want it to use that. Maybe they have their own. But if they have their own go.work, it doesn't blow it away. You see what I'm saying? But it's completely unused now. If I do a go build, it'll still cause a problem. Let's like reverse it. So let's say, do I have zgo off? I guess I must not have it anymore. I think I took it out of my composite. I did because I was working on it. So anyway, so let's move go.work to off to go.work. And let's go ahead and do a go get. No, let's do a build. Go install.cmd. That will build and install greet. And this should work. Directory outside modules list in go.work or their selected dependencies. I was afraid of this. Directory command greet outside modules listed in go.work. This is because of the subdirectories, so we might have a problem with this. I haven't hit this one before. I want to fix this. But this is how you fix it, though, is with go work. Oh, no. Of course. Oh, God. I forgot. Whenever you use go work, you need to do go work use dot too. Yeah, let me try and see if that works. Yeah, that was it. You have to do it so often that I forget to do it. Why not copy the imported package into the current project directory? Because unless you're vendoring and you want to be sure they're always saved with your project, if you want to stick with the external dependencies and pull them in like, Go is designed to do, then the only time you would ever pull in those packages is because when you do that, then you lose the ability to update those packages with the go get-u. If you do go get-u and you want to force an update, Go will remember the version that you have, right? But if you copy those packages in there, then it's gonna mess you up, right? Because you might have a different version. So this gets around that problem and allows us still to use a go get-u. We haven't gotten into package dependencies and stuff yet a lot. We are doing it now, unfortunately, but go get is what goes out to the internet and gets that dependency and brings it into your project. But if you call a go get on something that is in your work, it'll still be ignored and it'll get it, but it'll still use the one locally until you change your go.work to not use that. And you could even remove it from go.work if you wanted. So here we have dot. And we had to add the dot in order for go work to go get even its own stuff from there. And so that now we have greet, and then greet should work. Okay. So my name is Rob. Nice to meet you, Rob. Okay. So it worked, right? It worked. It got past the compile problem and it's there. Now, as soon as I want to commit this though, I would want to say go.work to go.work.off. And now if I try to do exactly the same build, it will fail. So install, remember, is a build and an install into my binary path. So to do that, it's like, no, you have to go get it. So as long as go work is enabled, it's like, we're all good. I know where to go resolve this for now, right? But as soon as you do this, it's like, no, you need to go fetch it. And as soon as they do that go get command, we all know what's going to happen. We already did it, right? It's going to say, I'm sorry, that doesn't exist because we haven't committed it to GitHub yet. Okay. So we're going to paste that and it's going to, I don't know what you got. I don't know, man. Now, here's the thing. I Dynamic linking is probably the wrong word. I wouldn't use dynamic linking. It's everything's statically linked. It just when it's doing the compilation for the static linking, it goes and gets this stuff. All this stuff, by the way, if you the kind of low level explanation, this stuff is all living in where I'm trying to think. Is it Go? I'm trying to find the I'm trying to find all the where all the lib is, all the libraries are now. Go env. I'm trying to figure out what my libs are. Oh, there it is. Home local share Go. The Go path. You see this right here? Your Go path is where all that stuff lives. If you want to see all the binary stuff as it's doing it, so you can go into .local share Go, and there's your packages, right? So you can see all these things. There's all these packages that are in here. Everything we've ever used, every checksum of every version. So, you know, anything that I've ever pulled in at all. And you can go see all the mods, and the mods are all organized. So this is what, when you do go get, this is where it gets it. Or if you're doing a go install, it does it automatically. And you can see, like, here's anything that I've ever built that's needed a dependency is here. So like there's the Cobra stuff. There's my stuff is in here. Here's like all of my versions of my different functions, my different packages that I've written, including our silly little greet ones, right? As tree is a package, yeah. What is this tree? Tree is yeah, tree's an optional thing you can install. Yeah, so like tree / Etsy, it'll give you a nice pretty picture of your organization. Yeah. So anyway, that's kind of a deep dive, but so the moral of the story is use Go work and be happy. So I'm actually going to do this git status, and I'm going to update git commit. I'm just going to update the changes in this directory. So git add dot. I'm going to add -a dot. Git status. It should only be the stuff in this directory, right? So I can make a git commit message, and I can say factor. Always start with a verb. Factor out. So the way to write these messages is you say this. You say the thing. It's not a bonsai tree, no. So, so we can say the words. We can when we're writing a comment, we should say, if I apply this commit, it will, and then what? You say it will factor read line into own CLI package. No dot at the end. That and under the 50 characters. Those are the standards for commit messages that are followed pretty religiously all over the place. There's still people who don't know this, so I'm just going to say it. And so that gets us, we get status, and we see we've got, only our new work here. We have the term colors we did last week, which apparently didn't get saved. So let's actually commit that. So let's say git commit. Let's actually add the term color stuff. Yeah. So let's just add the 19-week stuff. Notice these commits haven't been pushed yet, right? So git status, git add, what are we on term colors? 19. Yeah, add dot -a, git status. Okay, so now that's everything from here. We could actually do a git commit -p to do the readme part that replies to that. So yes, we want that. That's adding two things at once. That's hard because I wanted to break that into two commits, but I'm not gonna be able to do that. So we'll keep that hunk differently. It's because they're right next to each other. So anyway, git commit -m add week 19 term colors, etc. Git status, git log shows us all our commits from the beginning of time. And if you want to just look through those. Okay, so Um, and then let's start with a git status. I say git add dash a dot git commit. We'll do it interactively this time. So add week 20 and git status. We should have everything committed. Oh boy, we got to add that one. So git add dot readme git commit dash dash amend to fix the previous one because we forgot something. Git status, and they're all there. And now we're in week 20. And we can go week 20, we can go back in 8-ball. We're all good to go, right? So, but what I wanted to show you is after, because we're ready to commit now, okay? And what time is it? We're probably close to the end here. We got an hour left. So let's go ahead and commit, okay? I'm committing early, but I'm not talking about just committing. I'm talking about pushing, okay? So we're going to get, so we got all these queued up messages. So git status will tell us we have 3 commits that have been made, but we haven't pushed them. And there's nothing wrong with, 6 o'clock is when we're done here. So git push, we'll push all of these things out. And I want to show you how it changes the greet function. So as soon as all this stuff is pushed, now we can go back to the was it 18? We get 18 with greet. And you remember go mod not working? Remember that? Remember the go install not working? Because it's like, I have no idea. It's still going to fail. It's still going to fail. Watch. It's like, nope, you have to go get that. You have to install that. So we're going to go get, and I don't want to type that. So I'm going to go up and grab it. Paste. Oopsie. Go get, GitHub. So, and it still failed. Interesting. I wonder why not. This time it should have worked. Did I put upgrade? Did I put upgrade at the end? All right, go get -u. This should still build. I have a problem here. We gotta figure this out. GitHub.com, RWXRob, boost weeks. Maybe it's because the other one hasn't been installed. Maybe it's because the work is there and problem. Maybe it's because it's got the wrong package name at the top. Modificative found. Uh-oh. I was afraid of this. You remember before, a long time ago, when we got started and I said I wasn't sure if you could put multiple modules in the same repo? I think that's what the problem is. Because look right here. It says it found RWXRob boost. Go module upgrade found in blah, but does not contain this. And that means there's something going on. This is new information for me because I it's really bad form in my opinion to have multiple go modules in the same Git repo. I know that there's a lot of monoliths that do this, but I don't have experience with it, and that's what we're getting burned by. So, and this is actually one of the things people complain about Go the most is the management of all the different modules and where you put them, whether it's a module or it's just a package. So let's go back and see if we can fix this one. This is actually kind of cool. I want to figure this out. So GitHub RWXRob boost is where we're at. This is not a module though, and I don't understand why it thinks this is a module. Go module boost up at upgrade found. Copy paste the code. Stragger, no, I'm not copying and pasting. Which is a way to do it if you don't want dependency hell, which is obviously, sometimes that is the best way to do it. Because you know the code's never going to change. You're never going to want an updated version of it, and you don't want to deal with dependency hell. So sometimes it most definitely is okay. And that's definitely from the low-level world. People do that all the time. But in this case, I don't know if I would go for that. I mean, I can come back and reserve that I can fix that. I think people want to see that fixed. This is a new error that I haven't seen before. I've never seen @upgrade found before. So that's definitely new. I have a feeling it's because we haven't installed the other one. If I go into if I go into the weeks here, and I go into weeks 20 CLI, right? And if I do go install, I think that might actually fix the greet problem, but it may not. Let's go see. 18 greet. Go get. No, let's do go build.cmd greet. No, it still wants it. No required module provides package GitHub artifacts boost weeks till I still like to add it. Am I typing it wrong? I mean, normally you wouldn't have that deep of a package name either. It would just be on the right on the surface, right? GitHub artifacts Rob boost weeks 20 CLI. No, it's fine. It's CLI. Go.mod. GitHub artifacts Rob weeks 20 CLI. Boost weeks 20 CLI. Interesting. No require module. Huh. Yeah, I don't know. This is part of that problem I was afraid of with the whole, but I'll have to figure it out. GitHub Rob boost weeks CLI. Go get package keyword in the source file. Yeah, which one? This one? The CLI one. Yeah, that's always a problem as well. Package CLI. CLI test. Yeah. I mean, we know it worked because I compiled it with when I used the go work. So the go work tricked it into working. Which means that the stuff's all named the same properly. It wouldn't have worked if I hadn't done that. So this is something to do with the Git repo. You know what it is? Oh, I know what it is. Oh, I know. I just figured it out. Yeah, the branch. Yeah, it's not the main branch. It does matter. Yeah, that's what matters. That's exactly it. Yeah, and I haven't tried to do that yet, and that's exactly what the problem is. We'd have to commit that to the main branch for it to pick it up properly. Yeah. Yeah, I'm trying to think about how we can get around that. So, yeah, people don't know what branching in Git is yet. Most of the people here are gonna honestly they're gonna be doing stuff to main, which is a bad idea long term. But I don't think you can indicate branch. This is kind of cool for me to learn because and this happens in the boost all the time. I've never had to specify a different branch in an import. You know. I mean, I could do it and go work. Maybe that's something we could do as one of the what is the redirects in the go mod file. Yeah, this is cool. If you're a beginner, I'm so sorry. I know, but this is really fun for me to do right now. I want to figure out how to import a branch on a different branch from GitHub. I've never done it. So golang import module on different branch. And I think it's in the go-a. Did it measure git? That's completely wrong. That's also completely wrong. It's old data. With go modules, specific branch. Doesn't set the version. The version you're attempting to use will be recorded in go.mod. Replace. So replace is a directive I normally use, right? If you're not using the correct version at all, fetch it with go get. Yeah. No, it's probably I think you have to pull it from main. I the only way around that is to change the replace directive, which is usually not something you should use, right? See, this has require. And this is fine. Fine is the see the required directive goes in the go.mod file, and I don't want to get into that. Generate pseudo version of app. We don't want a version. We want a redirection. Oh, there you go. At. You can manually check out the branch vehicle. Get. Oh, let's do that. Let's do that. Okay, let's do that. Let's do that. Yeah. Okay, that was it. Yeah, I bet that's it. Go get at 2022. Yay! It worketh. It worketh. You know what else it did? It probably updated my GoSum. Yes. Okay, there we go. So it did. It upgraded my GoSum file, which has the exact hashes of the stuff that it included. No, we didn't. We just fixed everything. Yeah, I forgot the at because I was using like at latest. I thought you had to do versions, so those are really just tags the whole time. I should have just done. You can do at branches. It never occurred to me. I've always just done it for at tags. You know, that definitely fixed it. And that probably added a go.mod file too. Yep. See this? I automatically added this for me. It's like you're gonna add a tag. Okay, I'm gonna show you where that tag is, and it put a sum in there, so it's tying it to. That's so cool. I've never had to do that before, but this I only had to do this because I'm using branching on the boost directory. That's the only reason I've ever had to do that. At hashes as well. You can. There's like controversy about whether you should commit go.sum or not. You probably should though, because that would lock down your project to that version, right? So yeah. Yeah, I'm actually going to add mine right now. Yeah, let's go see everything that changed. Git status, git add dash a dot, git commit, add 2020 branch for greet depths. All right, so git push. Alrighty. All right, so we have a greet now, and I should be able to build a greet now with that factored out thing. I mean, that's probably more than you wanted here, but I had fun on that one. So it's kind of a two-way thing. So greet will install, no problem now. Greet, boom, boom, boom. And you notice my go work is off, right? So my go work is off. If I turn the go work on again, if I want to work on stuff locally, then I can do all that work before I commit it, whether it's the same auto repo or it's a separate repo, and then I can switch it off by just renaming it. So that's a practice. I don't know if that's a standard thing. That's just the way I've been doing it. Before that, though, the only thing you had was that replace directive, and it was a pain in the butt. It was really hard to manage. So yeah, I don't know if we're going to be able to. You cannot go get stuff with replace directives in the go.mod file, but I don't think that applies to commands. I think it's only to packages. Anyway, so we're back to the CLI. All of that trouble for what? We just wanted to factor out our little read line so we can use it in two places, or we can just without copying and pasting the code. It's the beginning of, a reusable library. And, depending on who you are, if you're coming from NPM land and Node, they factor everything out, right? If you're coming from Go, they tend to copy code, C++, Go, people like that. They'll tend to take their dependency code and they'll put it in their source code and lock it down at that level. And if there's a change, they'll move that change by hand and inspect the code. They're very careful about that. So there's there's two different general approaches to dealing with code dependencies and factoring. And they are very hotly debated. I land kind of in the middle of that. I tend to shy away from mono repos. I tend to keep one Git repo per package, except for at work where I have a mono repo, which has, many of the same packages I have in public and single repos. I personally think that if it can be versioned, that it should not have more than one in a repo. And that's why I don't believe in putting multiple Go modules in a single repo. I think that's bad. I'm doing it for the sake of the boost because it's all the code's there, but in general, I would avoid doing that. I would make a different Git repo for everyone, and do it that way. It's tough though because you have to go get -u every once in a while to update all the dependencies because you can get lots of dependencies and then dependencies on those dependencies, and that is one of the areas that Go gets pretty heavy critique because it's so safe. It does not let you just put shit in there randomly. Sorry for the swear word, but it doesn't. It's very careful, and more careful than any other system that I've ever used. Way more careful than NPM. It's responsible for the biggest worm in history. So I think it's worth it. We're at 5:29, so we have 30 minutes, and we're gonna just plug on through here the last project here. So we got our args, we got our 8-ball, and let's go ahead and finish our 8-ball prompt, shall we? Let's go ahead and finish that. We don't need to talk to greet anymore. Okay. Using go get to update dependencies. Learned to use at 2022 because of boost repo branch. I'm putting that for my own sake. And finished magic 8-ball. I wish we could do show and tell, because I would love to see everybody else's magic 8-balls. This is the that sounded weird, but this is the part of the whole mentoring thing that I really regret, because I can't get excited about the code you've written. I have to imagine you making cool code. Usually at this moment when I'm doing live mentoring, I would let you code for a while, and then you would come back and you would say, Mr. Rob, look what I made. And I would be able to say, oh my God, that's so cool. Or how about this? Or, oh, that's silly. That's very creative, and blah, blah, blah. And I can't do that right now. Right now, I just have to trust that, you're making cool stuff. There is in the Discord, my friends, there is a boost, channel, and there's also a show and tell channel. So I don't care how simple your code is. If you want to go show off your code and say, hey, look what I made, do it. It's actually kind of a fun process. It also encourages peer review. And, you all are reviewing my code all the time. So, put your code out there and let people go see it and make comments on it and make it kind of a community thing. So, because I missed that part of it, because the rest of this stuff is just stylistic, right? The stuff that we're doing now, the continuation of this stuff is very stylistic at this point. So here's another look at this prompt that we made. Is there anything about this prompt function that belongs in here? Is there anything about this prompt function that could not potentially be added to our CLI? I think that's a candidate for factoring out. What do you think? So we're going to go put that prompt function into our new fancy dancy CLI. And I mean, we can even make our own library. We can make our own thing, prompt out whatever, or we can just put it in here. And we can copy and paste it as is. Remember when I said it's great to default to exported functions with capitals and put them internal if you don't want people to depend on them? That's why. Because I just went to that thing, copy and paste it with no changes to any of the code, stuck it in an external dependency, and the only thing I have to change is the predecessor, right? So instead of this being greet readline, I don't even need that anymore because now readline is in the same package, right? So now I'm good to go. Now, what's going to happen though, right? So I should probably make, some tests here for it and other stuff like that. I could probably get, let's be real here. This doesn't need to be here. This is a tiny little module so far. Let's put this all in CLI. If it gets crazy, then we'll break it out. But for right now, let's put those two functions in the same thing, right? Oopsie. And we're going to move readline underscore test to CLI underscore test.go. File names don't matter. And I think we already have this one here, yeah? Oh, two of those. And then we can remove this readline. And we're, now we have someplace to add more test code if we want to do that. That is a lot to do. Kind of running out of steam, but you should probably do the test case for prompt, right? The tough part about prompt is that it does block and wait on input. So you'd have to do some really creative tests to mock that up. You'd have to simulate standard input and output and stuff. And we've already said that sometimes that kind of testing just doesn't make sense. It's not worth the time to do it. It's better to actually write a program that doesn't have a human in test it, in my opinion. So readline takes IO reader. It does take, prompt just takes a bunch of arguments. But we don't have a way to hand off the IO reader to it, right? Wait a second. Val equals readline. Oh, we haven't even finished that yet. All right, so file names don't matter. It gets the import names from function names. Yep. Yeah, the import is the package name. Yeah. Okay, so when you do an import, at the top of the file, that is the internet path to the module, right? But the prefix that you use will be the package name, and they're usually the same. In our case, they are, but they're not always the same. That's very different from Python, definitely. Yeah, they're so basically any file that's in this directory is as if it's all in the same file. Yeah, it does not use file scoping of any kind. And in that sense, it's a little bit like JavaScript, old JavaScript. So we do have a problem here because it's going to call readline, and readline wants an IO reader. So we actually could write a test for this. So we need to do, we could do this. We could make our prompt take, again, so sometimes the testing is dictating our structures because it'll be testable. If we pass the thing to read from, right? If we pass the thing to read from, then, we're good to go for our test. If we don't, then we have we have to infer what it's going to be, and that's very hard to test. So let's say we can pass that in there, and we can do that. Val equals readline in, and we can actually test this one now. It's weird because we're working in we're writing, this 8-ball program, and instead we end up editing the CLI library. But it's reusable code at that point. CLI underscore test. We have an example readline. Let's make sure our tests pass here. Let's get this one out of the way for a second. Misfetch readline returns 2 values. Okay. Readline returns 2 values, apparently. So CLI.go. This returns a val and an error. This is always a tough one because the error, it's like we already defined val up here, right? So I'm going to go ahead and do this. You could also declare error separately. And then we're going to say, there's a couple of idiomatic ways to do this, but if there's an error, and this, I like to log my errors, but a lot of people don't. So, especially if we're returning a string, another possibility would be that we would return an error here. So this is returning it. That's not the proper thing to do. Let's do the right thing here. Let's just do the right thing here. Let's do read line in, and then we get rid of this, and then we change the return values to match the same signature, which is why there's so many things that return an error. And now we have like idiomatic go. That's the way to do that. And client CLI underscore test. We're going to turn, we're going to do this. We're going to copy that example test and make us a prompt. I mean, prompt is, the same test essentially. So we'll make a new reader called sample. Line equals error CLI read line. And then we'll change this to prompt. And we'll just leave it be the default. And actually, we can have two of these. We could have underscore default. And that should mean log error print of error and return. So that should do it. Cut. Wait, did I change it to prompt? Yeah, I did. Start declare not used. Not enough arguments to call the CLI prompt. Oh, right. We changed it. Oh, shit. Ow. This is one of those cases where the test code has caused me to rethink my design. Happens a lot, and I think that's why early test-driven development is important. Because I am making the arguments like a variable string, right? It's probably a bad idea. Why don't we just make it a prompt? We just say, a string. And then, we if there's an A passed, we have it. Pump is that. So then we only have, then we don't have to do anything. We just say if we could use the ternary, but we're not. So we could say if A does not equal blank, then set the P to A, right? Equals A, and there's a little string copy there, and print it. So that's much more direct. It does mean that the signature is going to be very hard-coded. It's not going to be variable. But variadic function signatures can be, unless there's a really good reason for it, it's probably good to, I've been so burned by PHP having like 25 or, it seems like sometimes arguments that have to be nil, 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 blank, blank, this, that I like variadic stuff. So I tend to, that's a case where variadic was being wrong, but I caught it because I did a test for it. And I was like, how am I going to pass this in here? CLI prompt. So now we have to pass in a new reader. So we have a string reader, and we're going to pass in a blank. So this will be the default value, right? And let's see what happens. So go test. And okay, we got it print out the thing, and then it did sample. That's what we want. So we're going to change our match down here, and this will pass. Okay, and let's do the non-default value. I mean, there's two ways to do this, right? I think it's probably worth repeating the example test just so it'll appear as a separate thing in the documentation. But this we could say explicit, and we could say, something like this. And now down here, it should be dash dash like that. And we can run the test and it should pass. Okay. So, and both of these things show up as documentation, and our new change is in the house. Now let's leave CLI for a bit and let's go back to greet. Not greet, 8ball. So we'll go back to 8ball. And now the 8ball command is going to have some differences, right? So all we have is a respond in here, right? And we've got the test for that. But so what is our command actually doing? So we do ./command. 8ball may not go. Say welcome to the magic 8ball, and we could put the code here, or we could just do this. And you remember I said minimal run functions? I'm going to do it again. 8ball.run. And I really like minimal. I like everything to be in high level functions. I just do. I don't like putting stuff in main. There's a lot of people who do, but I don't like it. So, and this is going to panic as well, right? So run starts an interactive 8-ball session prompting the user for input and answering and then repeating until interrupted. So no timeout on the prompt. You can make that if you want. Yep, you could make that. Yes. So here we have run, right? So now let's just our main program has gotten really simple, right? So let's do that. But watch, we're gonna have a problem when we try to install this. Same problem we had with greet when we factored that CLI out. Can you guess? We're gonna have a problem. We're gonna do go install, and it's the same. And go work's gonna save us. It's gonna say, wow, that was interesting. I don't know why that worked. Oh, because we haven't called prompt yet. That's why. Yeah, we haven't even called it yet. Yeah, there's nothing in the way. So yeah, let's try that. 8-ball. We're gonna measure 8-ball. Okay, so we're almost there. We're almost done. So 8-ball.go run. We can welcome to the magic 8-ball, and you can do another one here. We're gonna enter your fd println. Enter your question, your yes or no question. Okay, and if you want, we could do this. We could say empty println. This doesn't have to be several lines, but I don't care. We could do what do we call it? Logo, art, into your question below. And if you want to put an extra one of these, you can. Okay, and then here's where we're going to loop. We're going to loop forever. So forever loop. It's called a forever loop. No things on the end of it. And then we're going to prompt. And then we're going to answer. Prompt and answer. Prompt and answer. So how do we do that? CLI.prompt. Prompt, if I could type. And I could find a magic 8-ball possibly. Wrong thing. Damn it. My skills are lacking. I'm trying to find... Why isn't it doing it? Give me a sec. There we go. I found it. Now we break it. Oh, now I break you. I just broke you. All right, so... Eight ball. There we go. So that's my prompt. Space. No package. I don't know what that's about. All right, prompt. And then answer. So mmt println answer respond. Respond. That's it. Print a response. Actually, I think we're about done. Yup. So we could actually run that from the test case, but it doesn't make sense to do that really. But now watch. Now we're gonna get those problems. Because we got those dependencies, and it's just like I don't know where to find it. I promise. I am very confident. I've been wrong before. Yeah, there we go. Undefined CLI. I don't know what you're talking about. So 8ball.go. We need to save this. And it should have imported the CLI. It did not. Why did it not? Oh, that's interesting, isn't it? So CLI.prompt is not a thing. So let's go back to the other one. It should have got it, right? So go install. Let's install this library and see if it helps. It just might not find it. Can't find it. Well, now what? It can't get it. It has no idea where to find the CLI thing. And we need to help it. Now I could type the import there. But I have a feeling it's going to fail. Usually if the editor can't find it, it's usually a problem. But we're going to try. So if we type, let's go back into here and get it. I think it is the branch thing, but it should actually still find it. In this case, it was finding it before, and we're going to use the go work thing as well. First of all, this CLI, I don't think this CLI is, oh wait, it kept it that time. It kept it that time. So that's just the editor was too dumb. Did you see that one? That normally wouldn't do that. Now it'll give us the go get problem. It'll be like, I have no idea how to get that. There we go. Now we're going to do the go get, and it's going to fail. And then we're going to have to do the thing with the branching, right? And then we could paste. And it's like, oh, I don't know what. So then we do this. We do go get, and then we do at 2022 because it's in the boost branch. Now you wouldn't have that problem, but I do. Okay, now I can do the build again. And, oh, it still says I can't find it. Why? Why can't it find it? Who knows? I know. Why can't it find CLI prompt? Because the last committed version doesn't have it. So how do I fix that? I can either fix it in CLI, but if I don't want to go fix that other one, I can do go work. Go work in it. Go work add dot. Sorry. Go work use dot. Go work use dot slash CLI slash the end. Yeah. And now watch. It will work. It should work anyway. That's a different problem. But you see, it got around that other problem. Now, when you use go work like that, you got to be really careful because you haven't fixed it. You might think it's fixed. You might push this code out without pushing the other dependency and the other package fix out. And then you have problems. I've done that with bonzai a couple times. So you push fresher code than what has actually been committed in this stuff because you did a go work and it worked. So you have to make sure to turn go work off and then have everything fail and go, oh, that's right. I need to go push those other things. If you're working on multiple packages at the same time, this is a real problem. So it's easy to get out of sync. And then people will try to use your code and like, why doesn't your code work? I mean, it's trying to get all these things. You broke it because you've got a dependency on newer code because of your go work that worked for you, but won't work for anybody else because it hasn't been committed for them. And it's annoying if you ever hit that because they're like, why doesn't it work? You're like, because the cache, dependency isn't there. Anyway, so this is actually a legit error. Not enough arguments to call the CLI prompt. Can you require a version? Yes, you can. Yeah, in fact, it does that by default. Yeah, and in fact, when you try to build it, it'll say that version doesn't exist. And it will fail. The build will fail. And you'll get a PR on it. You'll get a PR on your project that said you have a dependency on something that doesn't exist. But actually, that won't happen if you have a go work. If you have a go work, it bypasses all that. See, check it. If you have, well, let me see if this is true. Yeah, so here's your go sum and your go.mod. So see, this is the only reason this indirect is there at all is because of the 2022 thing. So it would still be a thing. Yeah, there's no more videos. So we're gonna keep going with this. I have one last thing to fix here, and then we can call it a night. At least for boost. I'm going to be back doing more Kubernetes stuff later tonight in case you want to join. I am going to be stuck in front of this computer all night. I am going to have a shower and eat and stuff and go outside for a little bit. But anyway, so welcome to the Magic 8-ball. We were prompting, but our prompt now needs an input, right? So this is good because now we can put os.stdin, right? And that seems redundant, but you know, it's good because you might want to change the input. Maybe you want to read from a terminal, like a TCP/IP input session. So you might want to be able to pass the reader. That's the first time I've done that this time, and I'm kind of happy about it. So 8-ball, enter. Yay! Welcome to the Magic 8-ball. Now, you can probably imagine millions of ways to add color to yours, to clear the screen. We added all that to our term stuff. Remember that? We made that other thing. Wouldn't those things be really great to put in a package as well? Factor those out into their own package. Probably a good thing to start thinking about, right? Put those into your CLI. All that stuff that we did when we did the term stuff. So, you know, we may or may not factor all that stuff into our common package so we can use it for all our other projects going forward. But the exercise of developing multiple things and factoring common stuff out into its own packages is a very, very regular occurrence in the Go development world, or any development world, frankly. So do that. You know, people are going to teach you to do that in a book, but they should, because that's the way development happens. A timeout on a prompt, a timeout on the prompt. That would be really great. And to do that, we would have to have concurrency. Jalopy, that actually, maybe we should do that next week. Because if to add a timeout, we actually have to add a go routine, which is a concurrent routine thread running in the background. That's actually a really great way to learn about timeouts and stuff. It's also a way to add random events and stuff like that. So I actually think we might do that. We could add some color. We could factor the term colors out, and we can make 8-ball. I mean, because 8-ball is a good example of a program that people like, that they can invest time in to learn all these basics. So are we actually done yet? No. Why not? Are you sure? Never. As a select statement as well. Yeah. A good example for the select statement is select which input. Yeah. You know what would be really cool? Somebody needs to do this out there in viewer land. Somebody needs to make this bind to a TCP/IP port. Yeah. It would be really great to make this bind to a TCP/IP port. It's completely set up to do it, because it prompts from any reader. So you can pass it a TCP/IP port reader, and you can have somebody initiate a connection to it through Telnet or SSH or whatever, and they could actually do the whole thing remotely. Yeah, and you could set that as that'd be fun. That'd be fun. You're like, hey, you know, SSH into this port to do this thing, or Telnet into this port. You know how they do like the animation for Star Wars? You go Telnet into this port and play Magic 8-ball. And hopefully you've done it securely so they can't break out and own you. That's pretty easy, actually, because this is a binary. If it was Python or any interpreted shell script, yeah, screw that. That's completely insecure. But because this is compiled, it's actually reasonable to do that. And you can do that with an interactive story game as well. That actually is kind of fun. We should do that. I want to do that. We can make an interactive Telnet Magic 8-ball program that anybody can play from their command line. And I mean, if you guys don't know what I'm talking about, has anybody ever done like weather? What is it? Weather. You can go get the weather. You can go get the weather from the command line. Yeah. Yeah. There's a bunch of programs out there that answer, and some of them are actually interactive, and others are, you know, Telnet interactive. So this is, you can curl that. This is like a one request, one thing, but there are things. Where's the Star Wars one? Star Wars Telnet. There's got to be somebody running it. Yeah, there's got to be a Telnet. But this is the kind of thing we could do with Magic 8-ball if we wanted to do it. If you wanted to allow other people to play it, you know. Telnet to, okay, there it is. Blinkenlights.nl. There it is. Yeah, you guys know about this? Telnet. I don't think I have it, but maybe I do. Yes, we do. Yeah. So long, and thanks for all the fish. The hard work was done by Simon. The IPv6 version has extra scenes and extra color support. ASCII Star Wars to its fullest extent. You should get IPv6. Wow. Presents. So this is Telnet, right? A long time ago in a galaxy far away. This is entirely done using the terminal stuff that we were talking about. And we could actually interactively play the Magic 8-ball program through that. Through Telnet. Yeah. It's not that hard. And it's fun. It's also how you can make an interactive chat program. All you have to do is on the back end, make it so somebody can type the answers, and boom, you got a chat program. So, yeah, it's kind of fun. No, we're out of here. Control D, C. I forgot how to disconnect. I don't remember how to disconnect. I don't know. They're owning my server. No, they're not. You need a server for that? For the telnet stuff? No, you can do it. You can do it from a VM. You just start up a separate VM. Oh, that's right. It's telnet. Duh. It's telnet. Silly me. God, I hate telnet. So scruffy. I fucking hate telnet. I hate it. Command, it's not, talk about not being able to get out of something. There we go. Quit. It was command control left bracket. There we go. I almost did. I almost deleted the tmux. I know. I just about did that. And I was like, no, I'm gonna do it right. My fingers were on it to do that, and I was like, no, I gotta do this right. Prove I can get out of telnet. Yeah, different buttons for sure. Yeah, I have a Mac too. I have a Mac keyboard with a Linux on Windows, running Linux, which is really crossing the streams. A different IP for home server than your different IP address. Yeah. I mean, we could do that. No, I mean, you could, if you want to share it with other people, yeah, it would have to be on the cloud somewhere. Yeah, obviously, but yeah, example-based testing versus ordinary unit testing to the summary. We already did that. Oh, you want that in the summary? I think we covered that last week, though. I could be wrong. Oh, we didn't have that in there. Oh my god, that's a good one. Right. Okay, so example based testing versus what do we want to call it? Ordinary versus testing, package testing. And yeah, it's kind of a rant about that. I must do that today with the terminal. Hey, last miles. You've seen that one, haven't you? I'm sure you've seen that one, haven't you? That's been around for a while. Kids remind me of this stuff all the time, though. They bring it to my attention. As soon as they know I like the terminal, they're out, reporting on things. Welcome, Last Miles is in the house. Perfect time to come in because I have somebody to raid now. Go stream, Last Miles. Because I'm done streaming for a while. I'm going to come back and do some more Kubernetes setup on my monster over there, which is finally all set up. Like all the machines are plugged in and everything anyway. Got OSs and everything. I've been using Ansible. The great Last Miles, Dennis Last Miles is in the house. Welcome. Stream something, anything. Okay, fine. Soon watching pay drive. Well, I don't know. We'll raid somebody. To the YouTuber people, thank you so much for being here. This is going to be up soon. We didn't get to all of our challenges, but we covered things that I wasn't planning on covering, actually. Your base and waffles will go pretty quickly, but I always say that. So who am I kidding? That's fine. We'll just Rasmus will raid somebody else real quick. And we have Keeper and a bunch of other really silly things, and ask a question over Telnet. Maybe we'll do over Telnet. Maybe so. We'll write our own Telnet protocol, which isn't hard. It's just using it over Netcat. Actually, you could actually do this over Netcat. We should do Netcat. We should do Netcat instead of Telnet. Netcat's way better than Telnet because reasons. Yeah, I think it actually echoes and everything too. Yeah, that'll be interesting. We'll try it. We'll try it next week. So there. All right. Bye, YouTube. It is